achieve that sustainability. So in that line of action, I would like to present a new concept. It's not a new concept. Already people have been working on it, but there are new advancements in it. So I will be talking today about eco-villages, the new paradigm for sustainable human societies. As we all know, our planet is facing many environmental crises and challenges due to pollution, deforestation, and loss of biodiversity. And we know that these challenges are also the result of our unsustainable human activities. So the human anthropogenic activities are really causing the overconsumption of resources. We are more reliant on fossil fuels, and we are using environmentally harmful technologies. uh, in line with the sustainable development goals, when we see the sustainable development goal 11, which talks about making cities and human settlements inclusive, safe, resilient, and sustainable. And as we know that most of the world population by 2050 will be living in urban cities. So according to that, the sustainable goal 11 was designed in such a way that to preserve these cities and human settlements, to make them more resilient and sustainable. So the idea is about to enhance this parameter, the 11th goal of Sustainable Development Goals, which is sustainable cities and communities. And when we see about sustainable cities and communities, there are various perspective and the various parameters that have to be achieved. It supports linking urban to peri-urban and rural areas. It supports increase of adaptation, city integrated policies. It supports least developing countries building resilient buildings. It also supports to ensure access to safe housing and services, provision of sustainable transport, and enhancement of inclusive and sustainable urbanization. Also to protect and safeguard natural and cultural heritage, reduce death, losses to disasters, and many more. By 2020, it also talks about substantially increasing the number of cities and human settlements, adopting and implementing integrated policies and plans towards inclusion, resource efficiency, mitigation and adaptation to climate change, resilience to disaster, and develop the and implement in line with the framework for disaster reduction. But we are still very far from achieving what we have set our goal by 2020. So how do we achieve it? We all know that urbanization is a process. We always believe that when we talk about urban, we are talking about big buildings, we are talking about huge infrastructures, we are talking about massive footprints of human activities. And we also understand that these activities are creating an effect on the whole globe, and this also is a big hindrances for sustainability. So when I talk about eco village, many people might really feel uncomfortable talking about village as something which are rural background. So how does cities and villages do really differ? Will be the major point of discussion here. In the earlier times, we see a drastic change in the landscape of cities and villages. But if you see in recent times, cities are a big magnet, but villages have also grown themselves to the level of the cities in the kind of infrastructure, in the kind of services they are providing. So in the earlier times, when you see village, there is no light, there is no internet, there is no telecommunication. But today villages are also having the same services and the facilities. But it's something like the cities are more like a attractive magnet of people, where you have lot more opportunities in terms of job generation and in terms of better lifestyle. That's what people perceive. But when I'm talking about eco villages, I'm not talking about eco villages in terms of magnitude. We are not talking about eco villages in terms of the facilities or infrastructures. We are talking about reducing the imprint of human activities on the nature. So we will move forward with it. So what exactly eco villages basically look at? So an eco village is basically a traditional or intentional community which is formed intentionally with the goal of becoming more socially, culturally, economically, and ecologically sustainable. And the eco village strives to produce the least possible negative impact on the natural environment through intentional physical design and resident behavior choices. It is consciously designed through locally owned participatory process to regenerate and restore its social and natural environments. Uh, just to have a brief look at how actually eco villages has been defined through historical background. The first clear line we can see in the Robert Gilman's definition in 1991, which talks about eco villages as human scale full featured settlement in which human activities are harmlessly integrated into the natural world in a way that it is supportive of healthy human development and can be successfully continued in indefinite future. In 2008 also we have Diana Mikkel Fischetti, who gave a definition which talks about intentional communities. So these eco villages are formed by people, by communities intentionally who want to do something with their life, and they want to be socially and environmentally sustainable. In 2016, there was a definition which was talked about by Kosha Anja, the director of Global Eco Village Network, and it talks about intentional or traditional communities. So there is an addition of traditional communities, and also it has very well talked about eco villages are both rural or urban settlements. So it wants to diminish this line of village means something which is more attracted or towards the rural perception, but it's more about both rural or urban settlements. And in the latest one in 2018, we have from Global Eco Village Network, which talks about participatory process in all five dimensions of sustainability, social, culture, ecology, economy, and whole system design. And we have to, through this, we want to regenerate our social and natural environments. So that was one of the major aim of recent aims, which was developed by Global Eco Village Network. So why we are talking about this? Because there is a crisis of because of our anthropogenic activities, and as I told you that as we have to sustain for a longer period of time, there is always a debate between natural and anthropogenic systems. So natural systems are already existing from the earth establishment, but anthropogenic systems are changing year by year. We are putting new perspective every time, and our demands are increasing, and we are becoming more consumer. So the problems of creating a favorable social microclimate is very important, because providing a variety of job opportunities that meet the aspirations and preferences of people, meeting the increased demand for housing. We have to guaranteeing high quality services, medical care and education, and also people are requiring leisure and recreational facilities. So there has to be an interaction of the settlements with the environment. Then on the urban ecology microclimate, we need to use of energy saving technologies, creation of favorable conditions for organizing and developing private housing sector, creation of convenient transport connections, development of energy save and inexpensive methods of construction. So these are the challenges we are facing in today's time. Also, we are also facing challenges of use of recycled materials and adaptation of standards and regulations in construction, recycling of waste, comfortable and healthy heating, cooling systems, supply and exhaust ventilation, providing a constant flow of clean air without effect of draft. So these all problems are really creating a friction between nature, the natural system, and the anthropogenic system that we are trying to build. So the principles of eco village tries to answer these frictions so that we can coexist. We can coexist with the nature. So the principles on which eco-villages rely can be applied to both urban and rural settings, as well as to developing and developed countries. So it is universal. It can be adapted in all cases. It advocates seek a sustainable lifestyle for inhabitants with a minimum of trade outside the local community or a eco region. Many also advocate seeking independence from existing infrastructures, although others, some people more in the urban setting, they also pursue that we have to integrate these existing infrastructure because we need infrastructures. Also, rural eco-village are usually based on organic farming, permaculture, and other approaches which promote ecosystem function and biodiversity. Eco-villages, whether urban or rural, tend to integrate community and ecological values within a principle-based approach to sustainability, such as permaculture design. And when we see the different aspect of the principles, so the principles are broadly categorized into four different aspects. The first one is culture. Under the culture, it is having vision and purpose. So you have to have a clear vision and higher purpose. You have to be mindfulness and reflection. Yeah. Hello.
No, no, you may continue, sir.
Okay. 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 Thank you. So we should have a connection with the nature. We should possess wisdom and innovation so that we can honor indigenous wisdom. We should celebrate art, and we have to enrich life with art and celebration. We have to defend and protect our communities and nature. So this is the culture which we have to bring inside an eco village. In terms of economy, in eco village, we have to reshape the concept of wealth, what actually wealth is, and what work and progress really means. We have to also ensure equitable access to land and resources. We have to be responsible in our consumption. We have to be social entrepreneur, and we have to use banking and currencies that strengthen communities, not like the existing one, rather than distributing the communities into high income, low income, and middle income. And we have to increase justice and collaboration with other people so that we can share our experiences. In terms of ecology, we have to grow seeds, foods, and soil through regenerative agriculture, because we have to respect the ecology. We have to see clean water cycles should be also respected. We have to go for green building technologies so that we have minimum effect on the ecology. We have to move towards 100% renewable energy and transport. We have to go towards zero waste, and we also have a very big responsibility for ecosystem restoration. So whatever has been destroyed by our earlier generation, we have the big responsibility to restore. So this is again a principle on the ecological front of eco village. On the social front, it talks about diversity and cohesion for thriving communities. We should have conflict resolution, and we should have clear communication, and we should do peace building skills has to be given to the society. There has to be leadership and governance. We have to be there has to be fairness and accountability, and we have to ensure that everybody has lifelong access to education for sustainability actually. Because the present education structure, we feel that once we do a college degree or once we do a PhD, the education is finished. No, we have to ensure that there has to be a lifelong access for education for sustainability, and we have to promote health and healing and well-being for all. So to do this, we have to have a principle for design, how we design a eco village from the perspective of conceptual approach. So we have to, in the design frontage, as a designer, as a planner, as an architect, we have to have certain perspectives in place so that we can start our conceptual design. So we have to do whole system thinking. We have to learn from nature and practice whole system thinking. We should have assets. We should identify assets. We should identify the needs and the leverage points. We should know the scale and the context. We have to make solutions which can adapt to scale and context. We have to be aware of privileges and use it for the benefit of all. And we have to have alliances across all divides. So we have to bring every knowledge together. The alliances of knowledge has to be created. Also, we have to ensure stakeholder engagement, and we have to disseminate the regeneration patterns towards different people. And we should also listen to the feedback of the world. We have to be a good listener. So depending on this, we had a project designed at Gircha. It is a small village in the upper highlands of Ethiopia. The nearest town is Arbaminch. It falls under the South Nations nationalities and peoples region. So the project stakeholder was developed by Arbaminch University. The project was undertaken under Arbaminch University. It was almost a 200 hectare site. The site was at a elevation of around 3,800 meter above sea level, and it was a rural area. And we designed a eco village proposal at that particular place. The concept which we took to design the project was cradle to cradle, that everything which starts should end at the same. So we should minimize our footprint and we should be going back to our basics. So the goal of the C2C cradle to cradle concept was to move beyond the idea of only reducing the impact of human activity by providing an engaging vision of positively conceived footprint on the planet, environmentally, socially, and economically. And C2C also, the concept also focused on improving quality to enable the generation of values for society through the following three concepts: intelligent material pooling, waste is equal to food or everything is a nutrient for something; eco effectiveness; and triple top line, which focuses on development that has positive impact on environmental system and it can enable long-term economic and social values. So the idea was to have eco efficiency, in which we optimize the positive effect, reduce the negative effect, and eco effectiveness, in which we optimize the positive impact. Uh, and also, when we saw the site, we tried to outline some built up areas which has to be developed in the site, because once we design anything on the site, any human is placed on the site, it itself is a challenge to sustainability. So we tried to put some interventions in which we tried to engage the existing landscape. Rather than cutting through the landscape, we tried to respect the existing landforms and try to make the buildings which are more suspended and which does not disturbs the existing landform. Here you can see we have floating floor levels which we try to use in the design. So this is the whole site which we designed at Gircha, and basically it had six different zones. So the first zone was this industry zone. Actually, it's when I mean by industry zone, it was more like a handicraft center and all those where people can exercise indigenous knowledge and they can generate income through the place. And the second zone was university zone. So this is a kind of concept which we derived for Eco Village. So this is a open learning university where people can come from any walk of life, from any educational background. They can come down and train people. They can share their knowledge and also get knowledge from respective other people coming from other walks of life and knowledge. So this is basically a knowledge sharing center where people learn among themselves, people teach each other, and people try to adapt whatever the surrounding teaches them. So this is basically something which without a degree, but we named it as the university because something which the whole universe can come together and learn from each other. The third zone was basically the community center, which we created for the community, the eco village community, like primary schools, healthcare, clinic, so that they can have certain kinds of services in that particular site. Also, we tried to give various activities. We'll show you later in the next slide. So we had a central plaza which would act as an amphitheater where the community can come together. They can, as I told you, that one of the major aspect is we have to celebrate art and also we have to celebrate our life. So this is the place where people come together, different kinds of activities can happen, discussions can happen, people can share their views, people can have arguments, people can have discussions. So everything, the central plaza will be acting for that. Then we'll have the residential zones where the people will be living, those residents from the eco village. And then we have a site for agroforestry zone where we try to create permaculture, where we try to do eco restorations through planting plants and species which are getting extinct, and also use the same for waste recycling and all those things. So this is the agroforestry zone. So this is something like the detailed site plan, in which we have the industry zone, in which there will be different kinds of workshops, training. People will be manufacturing handicrafts and other things. This is the university, where we will have a big library, open library. Then we'll have a lot of discussion areas. Most of the floor plans are mostly open. I have just a small time, so I'll just talk on the conceptual layout. And then we have a bridge which connects these two sides, because there is a lot of level difference, and you have a road right from the center, and you have this school for primary school, and you have clinic and first, you can talk about, call it as a clinic. And then we have different ponds, water collection ponds and other things here. And around here, we are also trying to design an energy center through which we can generate clean and renewable energy for our site, the whole project. We have different fish tanks. There are a lot of natural water mounts. Naturally, there are water collecting during the rainy season. We want to convert it into water mounts, and then from these water mounts, there is a level difference. This is at a higher level, and this is at a lower level. We also want to go for pico hydro projects, when the water flows from this area to this site. Then we have this huge plaza which overlooks the water body. We have the residential units and other things. So I will only give you some glimpses of what we are actually doing when we are talking about decreasing our footprint on the nature. So we have tried to adopt, the area is, the present area of Gircha is known for its bamboo production. It is having one of the strongest bamboo in Africa. So we tried to develop the structure using bamboo as a major building material. So we try to develop various joinery details and all those things, so that we can use bamboo as a very potential building materials in most of the project. This is some view of the university which we are talking about. So you have open plazas where people can sit, discuss, and move around, and they can learn from each other. So these are few aerial views of the school and the clinic, which is for the community. And all through in the landscape, we'll have different sitting areas, the natural sitting cut down areas. This is the energy park which I was talking about, which generates clean energy. Again, in the energy park, also for the windmills, we try to use local material rather than using steel. We try to use bamboo and wooden panels, so that these will be much more efficient. So you can see here also those wooden and bamboo panels to generate. So we have tried to use bamboo in that sense. Then we have plazas, different plazas which are going. So which I told you that these plazas will be the main for the communities to sit, discuss, and to have discussions with each other. This is something, the view of the high schools, the school and the community areas, the clinic. Also, we tried to develop interlocking load-bearing structures in the site. All the buildings, all the residences will be constructed with mud blocks. These adobe mud blocks will be completely interlocking, and they will be using a load-bearing structure system. Till now, most of the places where adobe is used, it's mostly used only for partition, but we are trying to develop it as a load-bearing structure which can almost support G+1 structure. So we have developed various details for the same. We have tried to see how we can make those houses with brick piers and all those with pier foundation system. Also, we have tried to develop sectional details for the bamboos, how the supports can be given, how the slabs can be put on top of it. So this is something how we are going to have bamboo, where the slab where we will use bamboo as the major support material, and then we will be filling back with adobe. So these are few details again of the windmill which we tried to construct with the bamboo. And this is the aerial view of the residential area. This is the community center, and this is something which we are looking at. So again, additional aerial views of the same. So thank you. Just to add on, I will say that this is a kind of experimental project which we have done till now, and many people in the world are still working towards establishing such kind of eco villages all around the world. And there is a good initiative from my dear friend in Una village who is also working in bringing these communities together. So if anybody is in touch in with such kind of communities, they can reach back to me and we can share more and learn from each other. That's the meaning of eco village, that you learn from each other. So thank you, and I would take any questions whichever are raised.
If we have any questions, yeah. Thank you, Rajendra Kumar sir. You provided us with a visionary perspective on the role of eco-villages as a new paradigm for sustainable human society. Your talk also illuminated the potential of these innovative community practices to foster environment consciousness among harmonious living. Thank you very much for your presentation. I request Dr. Pritam Singh to confer a digital token to Rajendra sir. Rajendra sir, kindly accept the virtual token in form of a certificate.
Thank you.
Thank you, sir. Ladies and gentlemen, please join me in welcoming Dr. Amit Goswami. He will be our co-session chair. Dr. Goswami works as an associate professor in the Department of Physics, Jagannath University, Jaipur. He has more than 15 years of teaching and research experience. He published more than 20 research papers in reputed peer-reviewed international journal, which has been indexed in SCI, Scopus, Web of Science, etc. He presented more than 30 papers in reputed international conferences. His research interests are quantum computing, quantum machine learning, quantum artificial intelligence, etc. We welcome you, sir. Following Rajendra sir's presentation, we have now privilege of hearing from Dr. Vivek Kumar Srivastav from VIT, Andhra Pradesh. Dr. Srivastav's expertise lies in the field of numerical methods, modeling and stimulation, computational fluid dynamics, multi-phase flow, biofluid dynamics. His lecture titled CFD Approach for Solving Realistic Problem promises to enlighten us on advancement and potential applications of these fascinating materials. Over to you, sir.
Thank you, sir. Thank you for inviting in this international conference. So I would like to share my PPT here.
Hello, sir. Srivastav ji, welcome you again. I am
Hello,
Dr. Pritam Singh.
Hello, sir. So first, I would like to share my PPT. I just switch off this video and share my PPT. So I think my voice is clear and this slide is clearly visible to everyone. Please respond so that I can start the session. Hello. Hello, sir.
Yes, sir. Yes, sir. Clear.
I think my slide is clearly visible
Yes,
to
sir.
everyone.
Clearly visible and you are audible also.
Okay. So good afternoon, everyone. The title of my talk is CFD Approach for Solving the Realistic Problem. So the outline of my talk is numerical method and computational fluid dynamics. Then I will discuss about the different area where the CFD is applicable. Airflow, fluid flow problem, and stress analysis. These are the things that I will discuss in this session. First, I would like to say what is the CFD. So computational fluid dynamics is the branch of fluid mechanics that use the numerical analysis and data structure to analyze and solve the problem that involve the fluid flow, like air flow or blood flow. It means where the fluid are involved, these help to find out the solution. So first application is the in aerospace modeling. So CFD play a crucial role in designing and optimizing the aerodynamical body like aircraft, rocket, automobiles. It helps engineers to study the airflow over the wings, the study of turbulence near the wings, drag forces that occur near the wing. So there has a lot of application of CFD in aerospace for the aerospace modeling. Second is the energy sector. Nowadays, CFD is used in the energy industry to analyze and optimize the design of wind turbine, hydroelectric power plant, and thermal power system. It helps engineer to understand the flow pattern and heat transfer mechanism, leading to more efficient and reliable energy generation. CFD is also used in automobile industry, like to study the turbulence near the surface of the car, also to study the drag forces near the surface of the car. This is also useful for the building design. CFD is employed to optimize the design of heating, ventilation, and air conditioning system in building. It helps designing the airflow pattern, temperature distribution, and ensuring the efficient thermal comfort and indoor air quality. The one of the major application of the CFD is nowadays to solve the biological problems like airflow. Just see, we can see here, this is the realistic human airways, or we can say that the human lungs, and this is the mouth, and then here the nose. The air is basically coming from this nose, which is also a fluid problem. So air is coming from the nose, then it goes to this mouth cavity, then trachea, and then lower part of the lungs. Now there are several type of problem involved in this biological system. So for first one is the airflow. So there are several dust particles which goes through this air and deposited in the lower part of the lung. So many researchers just in the two-phase study, they use the CFD for the analysis of different type of diseases in human lung, like lung tumor, and there are the several diseases in the alveoli region. Also, before 2 years, we know there is the corona. So there are several effect inside the lungs, and this can be solved using the CFD. So this is the first type of problem. Also, the researchers are using nowadays aerosol, means in terms of the drugs. So they also study these drug deposition using the CFD. So this is the two part, means one phase, that is the air, and the two phase modeling, that is the particle also they deposited either in term of the aerosol or dry powder. And this is the second part of the biological system, that is the human heart. We know the blood flow is also one of the application of the CFD. It means blood flow, that is the fluid flow. So many researchers basically increase the dia of this blockage, means heart blockage. Sometimes inside they artificially create a blockage and study using the CFD. So these are the major 5 areas that I have taken, which are nowadays at the top of the research. Now, how we solve this problem, that is the most challenging task. So if we can see here, there are the 5 area that I have discussed, or 5 problems that I have discussed. For each of these, CFD has the same role. Role means how we can use the CFD to solve these type of problem. So first challenging task is to create the model. That is the model, means the flow domain, where we have to flow the fluid. Second is the grid generation. Grid generation is the part that we divide the whole domain into smaller part, so that we can use the finite volume method or finite element method to solve the conservation of mass, momentum, and energy. This is the second part. So first we create the model. That is the first step. Second, we create the grid. Grid means just we divide the whole domain into smaller parts, so that we can analyze each of this part. And third part is the solver part, that is we use the governing differential equation where we apply the boundary condition, numerical scheme, also we set the convergence criteria. So, and in the fourth part, that is the last part, that is called the post processing, where we analyze the data. So total, if we have to solve any this real world problem, so first challenging task is to create the model, and second part is to create the grid generation. Just like this aeroplane, we have to divide the whole domain. Whole domain means where we have to analyze. Two types of study are there. Either we study outside, that is the airflow which is outside the wing, right, or near the wing. And second is the as I told, the air conditioning inside the aeroplane. So if we have to study the outside, then we have to create the domain outside. And if we have to study inside, then we have to create the flow domain inside. So first challenging task is where we have to analyze the data. So either we talk about this flow modeling, or if we want to study the airflow near these turbines or any thermal power plant. So first we have to create the flow domain. Or for this car, we have also created a flow domain where we have to study. Building also, we have to do the same thing. So first we have to create the model, flow domain basically, and then we do the grid generation. Third part is the governing differential equation, and fourth one is the post processing. So in post processing, we do the data analysis. Now there are several packages, means software, commercial packages are there. We can use that packages for the study of CFD. So this is just the CFD is nothing but it is just the extension of the numerical method. So now here I have already shown you 5 types of problem, but here I just focus on the biological problem, and government has granted a fund for this project that I have received for this human respiratory system around 14.43 lakhs for the study of these 2 types of problem. First, I have studied the airflow near the human lung tumor, and second type of problem that I have included, that is the drug deposition in the lower part of the lungs. So for which I have changed several parameters. One by one I will discuss. Second problem, I have received around 37 lakhs rupees from the Department of Biotechnology for study of the blood flow inside the human heart. So I have taken here the left coronary artery. Also I have received fund plant where fly ash is just use this CFD, and solar air heater that I have also received the fund from state government. So are used for low to moderate temperature application like space or room heating or crop dyeing or some industrial application are there. So how we can apply the CFD for solving the real world problem? Basically, there are 2 types of approach. We know nowadays if we solve any problem using either by numerical method or by some approach, first the important point is how we validate the model. For the publication purpose or for any purpose, if we have a valid data, then only we can go for the next step. So what we do, if we think about this human respiratory system, so first I have collected the data means CT scan data, and to create the 3D model. So first I have collected the 3D the CT scan data, and then I have converted this 2D slide set using in Mimic software. We have used this CT scan data in we have basically imported this CT scan data in Mimic software, and then converted and created a 3D model. and then we have used the ANSYS workbench for the grid generation, and then also we have used the ANSYS for the CFD simulation, and parallelly we have also we have created a prototype model for the validation purpose, and also I have used some data from external resources. So at the last, I have validated the model and conclude the thing. So this is the process. Now, pulmonary diseases, that is the first part, human respiratory system. Now, there are around 40 million affected population in India in 2010, and now it reached around 60 millions in 2018. So day by day, these type of diseases increases, and after Corona, it is basically the data is very weak. So now they have estimated around 50% increase by 2026, and now after the Corona, it's increased more. So how we do and how we can assist the medical practitioner in diagnosis, prognosis, and treatment of the pulmonary diseases. So CFD is one of the major application. We can assist the doctor by calculating some engineering parameter like wall shear stress. We can, after the simulation, we can tell and we can calculate the numerical value of the wall shear stress. There is basically a certain critical value. If we go beyond that, we can say that there is the injury or there is some risk factor is there. So locally we calculate the velocity profile and also wall shear stress near the tumor. Also, there are several other parameters that we can calculate and tell about the aerosol drug delivery in the human respiratory system. So I have basically changed several parameters like particle size. Particle size means the size of the drugs. Aeroflow velocity, I have changed. Injection velocity, on which velocity we inject the drugs. Also, I have changed the spray angle and spray diameter to optimize the drug delivery system. So these are the things that I have done. And initially, basically, I have created the old model. This is the first one is Webel model. Actually, this model is created by average of different people. Means we have taken a different dia and then we take the average. This is called the simplified model. This is not the actual model. And nowadays, 85% researchers are only working on the realistic, not the realistic model. This is called Webel model. The Webel has created this model in 1963. So most of the people are creating this model and simulate using this model, which is not the actual model. So only 15% person using this realistic model, that is CFD based model, CT scan based model. So I have used this CT scan based model, and two types of model I have taken. Not only the healthy person, but I have also taken the person which have having some diseases. So this is the model that we have created in Mimic software. So this is oral cavity, then trachea. First, we have created this model into two parts. This upper part, that is called the oral part, where we can insert the drug from the oral cavity. And then this is the lower part, that is called the lower lung or trachea. And then these are the different branches of the lungs. So I have only created up to 6 generation, but actually it is up to 32 generation. What is the major problem in CFD? As we go towards the lower part of the lung, the dia is very small and it is very difficult to create the actual dia. So even we have tried our best to create basically up to 6 generation for this study. And now see, these are the steps how we create. So first we have taken the CT scan data, then we have the 2D slices. So we connect all these 2D slices in Mimic software. First we have inserted in Mimics, and then we got this ring, and then we insert all these ring in ANSYS, and then we have created these data. So after creating this data, as I told, I have taken two types of model. First one is without tumor. This is the normal human lung, and here at the lower part of this lung, basically we have created the tumor, and this is not the artificial tumor. We have seen in many papers, basically medical paper, they have reported at this location, most of the drugs are most of the dust particle are deposited, and due to this deposition, there are the tumor is created. Basically it injured the this surface. And why this injured? Basically once dust particle inject here are inserted here, it due to the direct inertial impaction, it insert on this bifurcation junction, and most of the dust particle are deposited at this location. So we have taken the location from the some published medical papers, and we have created the tumor of the same size that was mentioned in the paper, medical paper. So then we have created the grid generation. Grid generation means we have divided the whole domain, flow domain, in smaller parts so that we can study the mass, momentum, energy of each flow domain. And now we then we have done the this is the part of this grid generation. We have to minimize the skewness, because if there is the skewness, then it will deviate the data, means we will not get the realistic result. Because if there is the skewness, this means that the gap in the flow domain. So we try to minimize the skewness, and we have found we have minimized this skewness at the means outlet, where there is no effect of the flow, because flow is basically coming from this inlet. So these are the parameters that we set in ANSYS Fluent. There are several numerical method, discretization method, and convergence criteria that we have set. Actually, for this study, I have taken two type of things. First one is the normal flow, normal inspiratory flow, means normal breathing that we generally take. And heavy breathing means if the person is running or there has some diseases, in that case the breathing is fast. In that case, every minute the person take around up to 45 liter air, and if there is the normal breathing, it is around 6 liter. So if the person is basically normal, its breathing is around 6 liter per minute. So we have taken two type study for in the case of tumor. This is the grid independency test. This is the part of the CFD. First we have checked whether the grid is independent or not, then only we can say that our data is valid. So for which we have also done the validation, because validation is the most important part. If we will not validate, we cannot say that our data is accurate. So we have done the validation, and we have got the good result. For this, we have done a several study, several parametric study, and we have found around 3.34% error that was published in 2004, and that was the experimental paper. So we have validate our data with the experimental. Now see the result. Actually, there are two types of model. First one is the normal lung, and second one is the lung that has the tumor. So we can see here, if as we go towards the lower part of the lung, first we have created several lines near several plane near the tumor. So before tumor, the horizontal plane is HOR1. There is no effect. And even before that, we can see as we go towards the tumor, the velocity is continuously increasing. Why? Because the diameter is decreasing due to the increase of the tumor. So as we go towards the lower part of the lung, here we can say that the velocity gradient is high, and there is the risk of the injury inside the tumor. Near the wall, we have a chances of wall injury. So after the validation, we have also shown if there is the heavy breathing, that is the 45 liter, then there has the more chances of the injury. And that's why we prefer, if you have a lung tumor or any disease related to lung, so don't try to put your effort in terms of running or other things. So here also we have done the same thing horizontally. Vertically we have also cut this plane, and near the tumor, vertical region 1, 2, 3, 4, we have seen as we go towards the lower part of the tumor, again the velocity gradient is high. In the similar way, average velocity, we can see there are two types of graph. First one is without tumor. We can see here there is no fluctuation if this I have drawn along this tumor. So there is no fluctuation if there is no tumor, with and without tumor. If there is the with tumor, in that case data is fluctuate, means near the tumor the velocity is very high, and then once the tumor is dropped due to the area, reduce of area, again it come to the position. So near the tumor velocity is very high. In the similar way, we have done these are the critical value. Yes, this is the wall shear stress. This is very, very important. Actually, this lower graph, that is indicate the graph without tumor, and this is the wall shear stress. And if there is the tumor, in that case wall shear stress is very high. And, we can see here the near the tumor wall shear stress is very high, which is above the critical layer. Basically, there is the critical value for injury the wall, that is 0.4. If we have a 0.4 Newton per meter wall shear stress, there is no problem. But if we go beyond that, beyond this critical value, there is the injury. So we have observed for the 45 liter, the wall shear stress is continuously increasing, and that is the reason. If there is the tumor, the wall has more injury. So also, this is the second part we have done. In the second part, drug delivery system, I have also created the drug delivery system and inserted outside this mouth, and then we have done the CFD study of this drug flow, and we have increased the efficiency of the drug to the lower part of the lung. Initially, actually, around 40% drugs are deposited inside this oral cavity, but we have tried our best to increase the efficiency, and what we have found latest, around 35% drugs are deposited at the 6th generation, that is the lower part of the lung. So these are the parameters that I have used for the study of the two flow. Particle type, I have taken the drug particle. Nozzle trip dia, that is the this nozzle dia which I have taken 2 mm. Spray cone angle, I have changes several cone angle like 25 degree, 45 degree, 60 and 75 degree to optimize the drug to the lower part of the lung. So I have found around 45 degree more drugs are deposited at the lower part of the lungs. We have also changed several particle size, means the drug size 0.1, 2.5 up to 10 micrometer. In the similar way, particle injection velocity, I have changed 5, 10, 15 and 20 meter per second. Air inhalation flow rate for the normal breathing, for the moderate breathing, for the high breathing, we have taken all these conditions. So I would like to now finally conclude the session. Even I have focused more on human respiratory, but there are several applications as initially I shown. There are the application in aerospace and automobile industry. Second one is the energy sector, building design, chemical and process engineering, environmental modeling, and biomedical engineering. That is that I have focused more. So these are the things that I have basically included in this session. If anyone has any question, then they can ask. Thank you for this session.
The platform is open for questions. I would request if anyone has question, they can raise their hands. Hello.
Yes, please. If anyone has a question, then please ask.
I think there are no questions. Thank you, Dr. Goswami. It was an enlightening presentation on the use of CFD approach to solve realistic problems. I mean, the depth of your knowledge and coupled with your ability to simplify these complex concepts was truly very impressive. And the uses of the practical examples and stimulation made the subject matter both engaging and understandable. As I'm not of your field, but then too I could comprehend most of the things that you engaged. And your dedication to this field is inspiring, and your ability to foster an interactive environment is truly it elevated the entire experience. Thank you for sharing the expertise with us. And your talk was a master class in CFD that has a newfound interest in, I think, most of us now. I request Dr. Pritam Singh to confer a digital token to Dr. Goswami. Sir, kindly accept the virtual token.
Thank you, sir. Thank you.
Thank you.
Thank you, everyone. Thank you.
Yeah. Now we have honor of hosting Professor Ansuman Srivastav, Dean of Research and Development at SIET Prayagraj, India. Professor Srivastav holds a PhD in Material Science and Engineering from the Indian Institute of Technology, Varanasi. His talk entitled Improving Mechanical and Dielectric Properties of PVDF Composites by Employing Modified Strong Polarized Particles Derived by Solid State Method will delve into his exhaustive research on enhancing the properties of composites of various applications. Over to you, sir. Can we have Professor Srivastav here? Yeah, thank you, sir.
Okay, let me share the slides.
Sure, sir. Yeah, it's visible, sir.
Is it visible?
Yeah, it's visible, sir.
Am I audible to you?
Yeah, you are clearly audible, sir.
Okay.
Thank you, sir.
Okay. So good afternoon, everyone. The topic of my lecture is improving mechanical and dielectric properties of PVDF composite by employing modified strong polarized CaCO3Ti4O12 compound derived by solid state method. So firstly, let me introduce you people about the basics of composite. So composite is a material system composed of two or more physically distinct phases whose combination produces aggregate properties that are different from those of its constituent. Examples are cemented carbide, wood, rubber mixed with carbon blacks, plastic molding compounds. Why composites are so much of importance today? That composites exhibit a very strong and high stiffness, even at a very low weight. So the strength to weight ratio is very high in comparison to many other metals or conventional material. Fatigue properties are generally better than conventional one. Toughness is often greater. Composite can be designed that do not corrode like metals. Composites possible to achieve a combination of properties which is not possible with the conventional materials. Even you can say that the alloys are of also same nature, but they are a very high. They are very high weight of high weight, so they are not. They can't be used for sophisticated application. So in this way, composites are superior than the conventional materials like metals and alloys, and the iteration of properties is very easy. But there are also some disadvantages and limitations with composite, that they are mostly anisotropic in nature. Many of the polymeric based composites are very sensitive to chemical solvents or sunlight. Composites are generally expensive too. Manufacturing and techniques are not very much explored till date. And the topic is mainly my topic is confined in with the polymer ceramic composite. As we see that today electronic industry is moving towards higher functionality, and with this development in electronic industry, we see that the miniaturization of electronic devices has become the prime objective of engineers and scientists working in electronic industry. So the need for high K materials are driven by the constant demand of modern electronics. A high dielectric constant material can store more electric energy than the one with the lower values. As a result, its use in electronic devices improves its efficiency as well as capacity. So the basis of electronic system is that they are mostly composed of active and passive components. An active component is an electronic component which supplies energy to a circuit like voltage sources, current sources, generator. We all are aware about these types of components. And as far as passive components are concerned, we know that the passive components can only receive energy, which it can either dissipate, absorb, or store in the electric field. And the examples are resistor, inductor, capacitor, transmitters. Passive components are nowadays passive components are attracting a lot of interest. For example, if you take the ratio of passive to active component in mobile phone is over 20. So, but the drawback is that the conventional passive components are bulky and they occupy a lot of space on the circuit board. And the next generation technology demands the passive component to be integrated into the substrate rather than being mounted on the surface as a discrete component. Here you can see that the graph from the figure that the percentage of capacitor is highest among all the passive components. So you can conclude, you can see that how much of importance capacitors are in case of if electronic, as far as electronic industry is concerned. And not only in case of electronic industry, high-K materials are widely used in many military and civilian applications like active vibration control, aerospace, underwater navigations, surveillance, hydrophones, biomedical imaging, NDT. So high-K materials are in very much demand and have become a potential candidate for various advanced applications at the present time. So now the question is that how we can synthesize and what are those different types of high-K materials that can be used in such applications. Lot of research work has been done, and the most promising material was barium titanate. But the drawback is that its dielectric constant is a temperature dependence. So if there is a variation in temperature, there will be a variation in dielectric constant too. So, and it is not good for the electronic devices. So the search for high-K material is basically motivated by these special properties that dielectric constant should be independent of temperature and frequency, and the loss should also be very low. So the oxide with perovskite structures are well known for their nearly temperature independent high-K. And one more thing is that it is environment friendly too, as they are lead free. So a ACU3TI412 compound family of compound has been known since 1967, but not much has been explored. The family was expanded in 1979. And there was a person, Subramaniam et al., who reported on a class of compound with a perovskite structure which have a high K properties, very different from the ferroelectrics or elixir like barium titanate and others. But in case of this was the data for ceramics, but the drawback is that they are they possesses high stiffness, excellent thermal stability, as well as high permittivity. But the drawback is this, that they show brittleness. And their processing is also a challenge because the ceramics are of brittle nature and the high temperature is required for their processing. At the same time, if we talk about polymers, polymers are possess easy processing, good mechanical flexibility, cost is also low, but the drawback is that their dielectric constant is low. Moreover, the integration of capacitor requires adhesive properties, which polymers have, but the ceramics lack. So there can be a good solution if we disperse the ceramic in the polymeric matrix, and therefore these kind of materials gain lot of attention. So to substantially enhance the dielectric permittivity while retaining its excellent mechanical properties, several types of dispersions were used by several researchers like metals, ceramics, carbon-based metals, conducting polymers. But the thing is this, that while using a conductive material, the drawback is this, that you have you can get a very high dielectric constant, but at the percolation threshold only. Slight variation in the percolation threshold results in a dramatic fall in the value of high dielectric constant. So the best suited material for such application is ceramics. And see, because they are such a percolation threshold condition is not in the case of ceramics. And at the same time, they exhibit a very high permittivity, low losses, adhesive properties, also good and easy fabrication if we disperse it in the polymeric matrix. Like different types of pillars, there are also different type of matrices like thermoplastic, thermosets, elastomers. They all are good candidates to be used as a matrix material. Among various polymers such as epoxy, cyanide, ester, polyvalent difluoride is widely used as a matrix material. PVDF is a semi-crystalline thermoplastic having remarkable thermal stability, high melting temperature, good chemical resistance, and unique piezoelectric and pyroelectric characteristic. PVDF and PVDF copolymers show widespread technological application in the field of transducer, transistors, capacitors, etc. From the literature review, it was found that lot of work has been done on barium titanate, but less has been explored in the case of calcium copper titanate dispersed composite. In case of barium titanate composite, the dielectric constant could not go beyond 50, even at a high content of loading. And in case of pure CCTO dispersed polymeric composite, high dielectric permittivity has been achieved, but at a very high content of loading, that is 55 or 60 volume percent. With the increase in the content of ceramic, what happens that the deterioration in mechanical properties take place. Why? Because of the agglomeration of particles and porosity, etc. It has been reported that increasing the content of ceramic adversely affects the adhesive property too. So to achieve high dielectric constant, greater than even 50, high filler content, filler loading more than 50 volume percents are used to be done, which drastically deteriorates the fill adhesion strength. As ceramics are mostly hydrophilic, the resultant material, the finally produced material also becomes hydrophilic, which is not good for the electronic instrument, because moisture negatively affects the electronic devices. So it has been reported that the increase in the content of CCTO, dielectric permittivity of composite starts showing frequency dependence too, due to the semiconductive characteristic of fillers. So earlier studies on these composites were confined to dielectric properties and lacked the mechanical properties. In our case, we have synthesized calcium copper titanate using solid state method, and the preparation of different types of composites were done using a extrusion method. Several characterizations have been done, like X-ray diffraction, scanning electron microscopy, thermogrammetric analysis, hydrophilicity nature, hydrophobic or hydrophilic nature of composite, tensile test, dielectric measurements, and the HN functions were also plotted using WinFit software to understand the dielectric relaxation behavior in depth. Ceramic synthesis has been done using solid state method, and these were the raw material these were used. Powders were in stoichiometric amount were mixed and ground for 12 hours. These were calcined in air at 1000 degrees centigrade for 12 hours with intermittent grinding. Formation of single phase solid solution was confined by X-ray diffraction. After the completion of calcination process, powder was again ground with and mixed with 2% PVA to make pellets. And the pressed pellets were sintered at 1000 degrees centigrade for 6 hours. Sintered pellets were again grounded to make fine powder using mortar and pestle. And the composite preparation were done using extrusion method. Films were developed by compression molding technique. Results and discussions are as follows. Now, if we analyze the results, you can see that here the X-ray diffraction, the diffraction patterns are shown for CCTO and PVDF and composites. In case of CCTO, all the peaks are indexed and matched with the matched. So it indicates that the successful formation of calcium copper titanate has been done using this method. And in case of PVDF, only alpha phase exists. So, and it is of semi-crystalline nature. And in case of composite, if you can see that in case of PVDF, 10 weight percent CCTO, 20 and 50 were prepared. In case with the increase in the content of ceramic, the peaks of ceramics are dominating the peaks of polymer because of higher content of ceramic loading. So all the peaks in case of PVD, in case of alpha peaks and the CCTO peaks, all the peaks are present in the composite too. So it is a clear indication that the successful formation of ceramic as well as the composite has taken place. As here the scanning electron microscopy images of PVDF and composites are shown. In case of PVDF, you can see that the PVDF exists in a spherulitic morphology. It is quite evident from the image, and whereas the CCTO is showing a globular morphology. And with the increase in the ceramic content, the morphology of the PVDF is getting changed into the globular morphology of the CCTO because the dominance of the ceramic phase with the increasing content. And at a very high 50 weight percent loading, some agglomeration was also found, but almost the dispersion is homogeneous. So it shows that the homogeneous dispersion of the filler has taken place in the matrix. If we analyze the TGA graph of PVDF and composite, we can see that with the ceramic dispersion, the thermal stability is increasing. We all know that the ceramic show high resistance toward temperature. So here the degradation temperature shifts to higher temperature with the CCTO dispersion, that is 442 degrees centigrade in case of PVDF, which increased to 464 in case of 50 weight percent CCTO. Slight increase has not much increase has taken place in case of 10 weight percent CCTO, but in case of 20 it reached to 456, and in case of 50 it reached to 464. So quite high increase it can be said. It shows that the addition of CCTO improves the thermal stability of the composite, which is very much required in case of required property for the electronic instruments and devices. Contact angle measurements of pure PVDF and the composites are carried out using press tensiometer K10 instrument. Here you can see that for PVDF, the contact angle was 72 degree, which for PVDF, it remained the same. PVDF put in 10% CCTO, it remained the same. But in case of 20 and 50, it decreased from 72 to 71 and then 69 for 50 CCTO. So here from these results, you can conclude that material is becoming slightly hydrophilic in nature, but still the difference is not much. So not these composite are not much hydrophilic, but still the hydrophilicity is increasing with the ceramic content. Here the graphs of mechanical properties are shown. You can see that the considerable increase was observed in the value of Young modulus. For PVDF, it was 750, which increased to 770 for 10 CCTO, and 865 to 20 for 20 CCTO, and 960 megapascal for 50 CCTO. So mechanical properties are improving with the increasing content of ceramic. The increase in the Young modulus value with the increase in the filler content can be attributed to the increase in the resistance to the free movement of polymeric chain because of the harder nature of the ceramic particle. This also explains the observed decrease in elongation at the breakpoint with increase in the concentration of ceramic in the PVDF, which is quite evident from the graph that the elongation is decreasing from PVDF to 50 CCTO. So now let us talk about dielectric properties. Dielectric permittivity of CCTO is around 3100 at 100 Hertz, which increased to 6800 and 9400 at 80 and 120 degrees centigrade. With the increase in the temperature, dielectric constant increases, and the value of dielectric loss for CCTO at 100 Hertz is 0.9, which increased with the temperature to 3.4 and 7.1. Here you can see the graphs of dielectric constant for PVDF and the composites that were prepared. Dielectric permittivity increases with the increasing content of CCTO. As the CCTO already we have seen that exhibit a very high dielectric constant. So the value for PVDF it was around 5.2 at 100 Hertz, which increased to 10 for 10 weight percent, which increased to 14 for 20 weight percent, and which further increased to 54 for 50 weight percent of CCTO. So these increase, this increased to 7.522 and 62 and 122 for respectively at 120 degrees centigrade at 100 Hertz. So with the increase in the content, with the increase in the content, the ceramic, with the increase in the content of ceramic, dielectric constant is increasing. And here you can see the graphs of for dielectric loss. The value of dielectric loss at 40 and 100 Hertz is for PVDF is 0.08, which is very low. But with the dispersion of ceramic, it slightly increased. For 10 weight percent, it reached to 0.27. For 20 weight percent, it reached to 0.26. And for 50, it reached to 0.25. So these are quite nearby values. So you can say that with the ceramic, not much change is taking place, but in comparison to PVDF, the dielectric loss increased in case of composite. But with the increasing content of ceramic, not much change is taking place in composite, especially in case of composites. In case of PVDF CCTO composite, one relaxation appears in the low frequency, which can be seen here in the graph in the lower frequency side, while other at the intermediate frequency range. And so the glass transition relaxation alpha PDF occurs beyond 1 megahertz, and these relaxation peak shifts to higher temperature with the increasing temperature, indicating lower relaxation time. From the high temperature graphs, you can see that these relaxation are shifting towards a higher frequency side, which indicates that the relaxation time is decreasing with the increase in the temperature. This seems to be due to the ease of relaxation because of the decrease in the viscosity of polymers with the increasing temperature. And here you can see the plots of modulus. Here the graph for PVDF and composite is shown, and from this you can see that the modulus M prime value is decreasing with the increasing content of ceramic, because it is the inverse of the dielectric constant. And here also you can see M double prime versus log frequency graph, that the relaxation can be seen in case of PVDF and as well as the composites, and the peak intensity is decreasing in case of PVDF, because it can be correlated with the dielectric loss. In case of the loss is increasing with the PVDF in case of composites. So loss was also increasing in case of composite in comparison to PVDF, and dielectric constant also increased in comparison to PVDF. So it is in correlation with that, those dielectric constant, dielectric loss graphs. And here you can see that with the increase in temperature, these relaxation peaks are shifting towards higher frequency, which has already been explained due to the ease of relaxation at higher temperature because of the decrease in the viscosity of polymers. And we can see that these two relaxation, one is because of the Maxwell-Siller type and relaxation, which is related to the heterogeneous type of, which is always related to the heterogeneous material like composite. And the one relaxation, alpha C relaxation, associated with the molecular motion of the molecular chain in the crystalline region, while the other is in the lower frequency range is MWS type. Height of the peak decreases with the CCTO dispersion. This shows that the dielectric constant as well as dielectric loss increases with the increase in CCTO concentration, which we have already seen and discussed in the dielectric constant loss graphs. Relaxation peaks are shifting towards higher side with the increasing temperature. It is also observed that relaxation peak shifts to lower frequency in composite with the increase in CCTO content. This is due to the restricted mobility of the polymeric chain because of their interaction with the high stiffness filler particles. And some model fitting has also been done. These are some models, Maxwell model and the Clausius model, logarithm model. But the results which we have obtained is best fitted with the EMT model. From this we have concluded that the experimental values obtained are closest to the predicted value in case of all the models employed to predict the permittivity prime values. The shape parameter n has been found to be 0.089. So from this shape parameter, we can say that the particles are of nearly a spherical type, which we have dispersed in the composite material. HN functions have been also plotted. Here you can see that it for PVDF and at 40 degree and at 80 degree and 120 degree for PVDF, and 58% CCTO has been compared. D by type relaxation is observed for the PVDF with beta value 1, while stress relaxation has been observed over a wider range of frequency in the composite, so, which can be seen from the graph. It shows the asymmetric nature of relaxation because composites are heterogeneous materials. Now, what we can conclude from this study and from this work is that PVDF has been successfully synthesized by solid state conventional technique, and the PVDF composites were also successfully prepared using the melt extrusion process. X-ray diffraction studies indicated no structural change in either polymer or ceramic or in case of composite. Some images shows the homogeneous distribution of CCTO in the PVDF with the smart rails of agglomeration at a very high content of loading, but almost homogeneous. Contact angle measurement showed that the hydrophobicity of the composite slightly decreases in the concentration range, or in other words, hydrophilicity is increasing with the increase in the content of ceramics. Addition of CCTO improves the thermal stability of the composite. Young modulus increase with the increasing of ceramic content. So it can be said that it is also good from the mechanical properties point of view. With the addition of CCTO, there is a substantial increase in the dielectric permittivity of PVDF. As the filler content increases in the PVDF, M prime value decreases. In the modulus spectroscopy, two dielectric relaxations have been observed in the composite. One is low frequency relaxation alpha C, another is the MWS type relaxation, which always exists in the heterogeneous material like composites due to a different nature of materials that has been used for dispersion as well as the matrix. Temperature dependent dielectric relaxation has been worked out in detail using a Chen function. D by type relaxation is observed in PVDF with beta is equal to 1, while the stretched broad relaxation can be seen in case of composite due to the asymmetric nature of relaxation, because of the heterogeneity of this kind of composite material. So these are the conclusion from the research work done by us. These are the few references that has been referred. These are the references. These have been referred for the research work, and some of the publication in international journal has already been published. These are the some papers. Thank you.
Thank you, Dr. Srivastav. Any questions? The floor is open for question. I don't think so. Thank you, sir. Your research on improving the mechanical and dialectical properties of PVDF composites opened a new avenues for material engineering. And your work also showcased on the importance of modifying and enhancing the properties of composites to unlock their full potentials in various applications. Thank you. Thank you very much for your kind words and for your presentation. I request Dr. Pritam Singh to confer a digital token to Dr. Srivastav. Sir, kindly accept the virtual token.
Okay, thank you. Thank you so much.
Thank you, sir. Now let us invite Dr. Amit Goswami and Dr. Sandra Carmel Sophia, the esteemed chairs of this plenary session, to share their valuable comments on the session. Sophia, ma'am. And Goswami, sir.
Yeah. So first of all, I would like to thank the organizers for giving me this real golden platform for chairing the session and listening to intellectual expertise of various subject branches. And I really thank from the bottom of my heart the organizers, because it's a privilege for me to be a part of this wonderful conference, which is really meaningful, and also lots of knowledge sharing has taken, and lots of information has been disseminated, at least on my part, to the audience. And I'm really proud to be chairing this particular session. And with utmost gratitude, I would like to thank the organizer, the convener, the organizing secretary, what names we want we may call, for really providing me the honor to chair the session for the very first day. Thank you, sir. Thank you so much. I'm actually not well, so that I don't want to speak much and take much of the audience's time. And at this juncture, I would be failing if I really thank and make remarks about the three speakers, beginning with Dr. A.R. Rajendra Kunwar from Ethiopia. And he has really enlightened the audience with his talk on eco-villages, the new paradigm for sustainable human societies. Sir, it has been a very elaborate session, and you have really given lots of input and lots of space for the audience to brood and also write papers on this area for publications. It was really a very wonderful, very comprehensive, and very excellent presentation, sir. Thank you so much. Thank you so much. And next, I have the honor of also thanking Professor Anshuman Srivastava. And sir has spoken about improving mechanical and dielectrical properties of PVDF composites by employing modified strong polarized yeah, sir, I'm sorry I cannot really prolong the title because it's not my cup of coffee. But despite that, I would just like to tell you that it was really a very, very excellent presentation. And we understand that research is not limited, it is not restricted or confined, and only scholars or academicians and audience will have to give a second thought, irrespective of what branch or what subject they are dealing or teaching, because research is again vast, it is huge and enormous, and it is nothing like mechanical or computer science or English language teaching or literature. I'm sure all of us, if you really put your heart and soul into it, you will really get lots of input and information, and that will really pave the way for researchers to write excellent papers. Because these days we are actually going in search of scopus papers, and for that, I'm sure topics like this will be of great help, and we can collaborate with our colleagues from different colleges and institutions and ensure that we can get our articles also indexed very much. Thank you, sir. Thank you so much. It was really a very nice presentation. And of course, I think I missed out. Okay, we have another speaker for this. We had another speaker for this afternoon, and that was, if I'm right, could you, Dr. Pushparaj, could you just help me? Dr. Pushparaj, could you just help me?
Yes, ma'am. Dr. Ansuman Srivastav.
Yeah, exactly. So only two speakers. We had three, if I'm right.
There are three speakers, ma'am. Vivek Srivastav, Ansuman Srivastav, and first one is the Rajendra Kaur.
Yeah.
Yeah, and what about Anuj Krishna? I don't think he has given.
So
only two.
Some health issues, they are not coming.
Okay, fine, sir, fine. So
In
we had
case
we
of
just had,
this Vivek Srivastav can join.
yeah. So thank you. So we just had two speakers, if I'm right. Uh, because okay, so really once again I would like to thank the organizers, the moderator for this session, who has given a wonderful introduction about me, and I'm really happy. Of course, he is none other than my colleague Dr. Pushparaj, a young academician and a scholar who is really good in his research, and he can speak on any, he can take over on any particular topic. So I thank Dr. Pushparaj also, and once again my heartful gratitude to the organizers for giving me this fine platform. Thank you all. I think for judgment it becomes very difficult, but still we will do the needful. Thank you all. Thank you for giving me this opportunity.
Thank you very much, ma'am, for your kind words. We extend our deepest appreciation to Sophia, ma'am, for chairing the session and ensuring its smooth proceedings. Your expertise and guidance will have greatly enriched our experience today. We would also like to thank you all the distinguished audience, for your active participation through thought-provoking questions. Your engagement had made the session resounding success. I also request all the participants to kindly be active in the polls and question answers. It has been posted online. And now let's move forward to our paper presentations. Now let's call the first presenter of the day, Ashish Kumar Meena. He'll be presenting on effects of solar flares on ionospheric TEC at Jaipur during solar maximum period.
He is not there. Please skip this, Ashish Kumar.
Okay, thanks. The second presenter is Priyanka M. She'll be talking on the topic microstructure and photoluminescence properties of yttrium doped ZNO nanoparticles. Priyanka, are you here? We have our third presenter, Praful Chabra. He'll be talking on the analysis of the latest parametric divergence measures. Praful, are you here?
He is not also there, sir.
Okay.
Next. Rakesh is also not there. Just
Okay.
call J. Ila.
Okay. Now I request J. Ilya. He'll be speaking on separation axiomoids of binary S alpha set in binary topological space.
Afternoon to one and all present here.
Yeah. Thank you. Over to you.
I'm J. Ilakya.
Yeah, you're audible, ma'am. Please,
Okay.
please share your presentation.
Okay.
Yeah.
Good afternoon to one and all present here. I am J. Ilakya. I'm going to present my paper on topic separation axioms of binary S alpha open sets. Visible?
Yeah, you're audible, but your presentation is not visible. Yeah, it's visible now.
Okay. The main objective of this presentation is to study the separation axioms of binary S alpha set, where T1 space, T2 space, and T3 space, T4 space are being discussed, and their relationship between all those spaces are being studied, and further examples are suitable examples are also given in this presentation. Binary topological concept is a topology from X to Y, which has been introduced by Jyoti. Here in this binary topological space, a new set called binary S alpha set is being introduced, and the separation axioms for this set is being studied here. These are the basic preliminaries which have been used for this separation axioms. So the main concept is binary S alpha T naught space. Definition for a binary S alpha T naught space is a triplet of X, Y, M is said to be a binary S alpha T naught space if for any two distinct binary points x1, y1 and x2, y2, there exists a binary S alpha open set which should satisfy the condition one point, that is x1 comma y1 should belong to that binary S alpha open set, and the other point belongs in the complement of that binary S alpha open set, and vice versa. This is the basic definition for a binary S alpha T naught space. The binary topological space XYM is a binary S alpha T naught space if and only if the binary S alpha closure of distinct binary points are distinct. Theorem, let x comma tau and y comma sigma be two topological space. If the binary topological space x comma y comma tau comma sigma is a binary S alpha T naught space, then the separate topological space, that is x comma tau and y comma sigma, are said to be S alpha T naught space. Next theorem is every binary T naught space is a binary S alpha T naught space, but the converse, that is binary S alpha T naught space, is not a binary T naught space. And the example and the suitable example is been given. Next, binary S alpha T1 space. A binary topological space XYM is said to be binary S alpha T1 space if for every pair of distinct points xi comma yi comma xj comma yj belongs to x cross y, there exists a pair of binary S alpha open set A S alpha comma B S alpha and C S alpha comma D S alpha such that one containing xi comma yi, but it does not contain the other point xj comma yj, and the other point xj comma yj but not the xi comma yi. In other words, xi comma yi belongs to A S alpha comma B S alpha, and xj comma yj belongs to the complement of that set. Similarly, xi comma yi belongs to a complement of C S alpha comma D S alpha, and xj comma yj belongs to C S alpha comma D S alpha. A binary topological space is binary S alpha T1 space, then definitely it is a binary S alpha T0 space. But the converse is not true. That is, binary S alpha T0 space cannot be a binary S alpha T1 space. And the proof is shown in this example. Every binary if every singleton subset x comma y of a binary set is a binary S alpha closed in x comma y comma m, then x comma y comma m is a binary S alpha T1 space. In a binary topological space, every binary semi T1 space are binary S alpha T1 space. But the converse, that is, every binary S alpha T1 space is not a binary semi T1 space. And the example is shown here where 2 points A comma B and C comma D is taken, and we have shown that it is a binary S alpha T1 space, but it is not a binary semi T1 space. Next space, Hausdorff space, that is binary S alpha T2 space. Binary topological space is said to be a binary S alpha T2 space if for every jointly distinct binary point xi comma yi and xj comma yj, there exists a distinct pair of binary S alpha open sets A1 comma A2 and B1 comma B2 such that X1 comma Y1 belongs to A1 comma A2 and Xj comma Yj belongs to B1 comma B2. In this space, every binary T2 space are binary S alpha T2 space, but the converse is not true. Similarly, the example shows that the above statement is not true. In a binary topological space, every binary S alpha T2 space are binary S alpha T0 space. But every binary S alpha T0 space is not a binary S alpha T2 space. And the example is given here. In a binary topological space, every binary S alpha T2 space are S alpha T1 space. But binary S alpha T1 space is not a binary S alpha T2 space. Next space is a binary S alpha T3 space, which is a regular space. In a binary topological space, x comma y comma m is said to be a binary S alpha T3 space or a binary S alpha regular space if the space should be a binary S alpha T1 space. And the second point is for every binary points xi comma yi, and there exists a binary S alpha closed set A1 comma A2 which is a subset of the topological space, and xi comma yi should belong to the complement of that set. There exists a distinct pair of binary S alpha point B1 comma B2 and C1 comma C2 such that xi comma yi belongs to B1 comma B2 and A1 comma A2 is a subset of C1 comma C2. In a binary topological space, every regular space are S alpha T0 space, but the converse is not true. Similarly, every binary S alpha regular space are binary S alpha T2 space, but the converse is not true. All these statements which shows that the converse is not true is proven in the following example. The topological space, that is a separate, we take two separate topologies, x comma tau and y comma sigma, which are S alpha T3 space, if and only if the binary topological space is a binary S alpha T3 space. Next, binary S alpha T4 space, which is otherwise called as binary S alpha normal space. The definition for a binary S alpha normal space is the binary topology is said to be a normal space if the space is binary S alpha T1, and for every pair of distinct binary S alpha closed set A1 comma A2 and B1 comma B2, there exists a pair of jointly disjoint binary S alpha open sets C1 comma C2 and D1 comma D2 such that A1 comma A2 is a subset of C1 comma C2 and B1 comma B2 is a subset of D1 comma D2. In a binary topology, every binary semi-normal space or binary S alpha normal space. Converse is not true is shown in this example. Similarly, every binary alpha normal space are binary S alpha normal space, but the converse is not true. In a binary topology, every binary semi-normal space or binary S alpha normal space. Converse is not true is shown in this example. Similarly, every binary alpha normal space are binary S alpha normal space, but the converse is not true. In a binary topology, every binary alpha normal space are binary S alpha normal space, but the converse is not true. a binary topology, in a binary topology, every S alpha normal space, that is S alpha T4 space are binary S alpha T3 space, but the converse is not true. In a binary topology, the binary S alpha closed subspace of a binary S alpha normal space is a binary S alpha normal. Conclusion, all the four axioms, that is separation axioms, T0, T1, T2, T3 and T4 space are being found, and the relationship between these four spaces are being discussed, and the statements which shows that the converse is not true is proven with the suitable examples. These are my reference papers.
Yeah.
Thank you.
Thank you very much. Now we call the next presenter S.S. Surekha. Her topic is a contemporary approach on various types of binary alpha G's continuous function. Yeah. Please present. Please present. Yeah, you are audible. Kindly present.
Okay.
Yeah.
Is it visible, sir?
Yeah, it is now visible.
Good afternoon, all. I am Surekha, doing PhD under the guidance of Dr. G. Sindhu. I am going to present a paper on a contemporary approach on various type of binary alpha GS continuous functions. This is my presentation overview. It consists of abstract, introduction, preliminaries, binary alpha GS continuous functions, binary alpha GS irresolute functions, strongly binary alpha GS continuous functions, and totally binary alpha GS continuous functions. Abstract. The primary aim of the paper is to discuss about the binary alpha GS continuous function, binary alpha GS irresolute function, strongly binary alpha GS continuous, and totally binary alpha GS continuous functions. Also, some theorems have been framed and examples were discussed for the keen understanding of the concept. Keywords: binary alpha GS continuous functions, binary alpha GS irresolute functions, strongly binary alpha GS continuous functions, and totally binary alpha GS continuous functions. Introduction. The binary topological space is a binary structure from X to Y, which was introduced by S. Nityananda Jyoti and P. Thangavel in 2011. They also introduced the concept of binary continuous functions. Surekha and Sindhu introduced binary alpha GS closed and open sets in 2022 and also discussed their properties. In this paper, we have investigated binary alpha GS continuous function, binary alpha GS irresolute, strongly binary alpha GS continuous, totally binary alpha GS continuous function, and also proved some of the propositions and created some examples which made the concept more clear. Preliminaries. First is a definition for binary topological space. Let us consider two universal sets X and Y. A binary topology is a binary structure M subset P of X cross P of Y from X to Y, which satisfies the following axioms. That is, the full set belongs to M and the empty set also belongs to M. A1 intersection A2, B1 intersection B2 belongs to M, where A1, A2, B1, B2 also belongs to M. Next, if A alpha, B alpha such that alpha belongs to A is a family of members of M, then union A alpha and union B alpha also belongs to M. If M is a binary topology from X to Y, then the triplet X, Y, M is called the binary topological space. The members of M are called binary open sets of the binary topological space. Next is the definition for binary alpha generalized semi-closed, that is binary alpha GS closed. If alpha closure of A, B is contained in U, B, whenever A, B is contained in U, B, and U, B is binary semi-open, if it satisfies this condition, then it is called binary alpha GS closed set. And next comes binary alpha GS continuous functions. A function f from Z to X cross Y is said to be binary alpha GS continuous function if f inverse of A, B is alpha GS closed in Z for every binary closed set A, B in X cross Y. Here is the example for binary alpha GS continuous function. Let us take the universal set Z equal to A1, A2, A3, A4 for the topological space tau Z equal to pi Z A1, A2, A3, A4, A1, A1, A3, A4. And let us take two more universal sets X equal to B1, B2, B3 and Y equal to C1, C2, C2. Using this universal set, we can frame the binary topological space as M equal to pi comma pi, X comma Y, B1 comma C2, B2 comma B3 comma C1. Now we define the function f from Z to X cross Y by f of A1 equal to B1 comma C1, f of A2 equal to B2 comma C2, f of A3 equal to B3 comma pi, and f of A4 equal to pi comma pi. Here, the inverse image of all the binary closed set is alpha GS closed. So we can say this mapping as a binary alpha GS continuous function. Next, every binary alpha continuous mapping is binary alpha GS continuous function. Also, every binary alpha GS continuous mappings are binary semi-continuous mapping. A mapping f from Z to X cross Y is binary alpha GS continuous if and only if the inverse image of each binary open set in X cross Y is alpha GS open in Z. The next proposition is let f from Z comma tau Z to X comma Y comma sigma be a alpha GS continuous mapping if and only for every Z belongs to capital Z and for every binary open set A comma B with f of Z belongs to A comma B, there is an alpha GS open set U contained in Z such that f of U is contained in A comma B. Next proposition is f from Z comma tau Z to X cross Y comma sigma is binary alpha GS continuous if and only if f inverse of binary alpha GS interior of A comma B is contained in binary alpha GS interior of f inverse of A comma B for every A is contained in X and B is contained in Y. And the next theorem is in a binary topological space X comma Y comma M, A comma B be binary alpha GS open set such that A comma Y difference B and X comma X difference A comma B are binary alpha GS open in X comma Y comma M. Then the mapping f from Z to X cross Y is binary alpha GS continuous if and only if the inverse image of the binary closed is alpha GS closed. And the next theorem is let us consider the topological space Z comma tau and the binary topological space X comma Y comma M. The mapping f from Z to X cross Y is a function such that Z difference f inverse of A comma B is equal to f inverse of X difference A comma Y difference B for all A is contained in X and B is contained in Y. Then the mapping is said to be binary alpha GS continuous if and only if f inverse of A comma B is alpha GS closed in Z for all binary alpha GS closed set A comma B in X comma Y comma M. Next is binary alpha GS irresolute function. The function f from Z to X cross Y is said to be binary alpha GS irresolute function if the inverse image of binary alpha GS closed is alpha GS closed in Z. Here is the example for that. Let us consider the universal space of the topological space Z equal to A, B, C. The topological space is defined by pi Z, A comma B and B. Let us X is equal to A comma B and Y equal to 1 comma 2 be the universal sets of the binary topological space M equal to pi comma pi, X comma Y, A comma 1, B comma 2, A comma pi, A comma B comma 2. Now let us define a function f from Z to X cross Y by f of A equal to A comma Y, f of B equal to B comma 1 and f of C equal to pi comma 2. Here the inverse image of all the alpha GS closed set or binary alpha GS closed. So we can say this function as a binary alpha GS irresolute functions. And next is T alpha GS space. A binary space X comma Y is said to be T alpha GS space if every binary alpha GS closed in it is binary closed. And here is a theorem for it. In a binary topological space X comma Y comma M, every binary alpha GS irresolute functions are binary semi irresolute function, and every binary alpha irresolute functions are binary binary alpha GS irresolute function. And the next theorem is a function f from Z to X cross Y is binary alpha GS irresolute function if and only if the inverse image of every binary alpha GS open set is alpha GS open in Z. And the next theorem is if the function f from Z to X cross Y is binary alpha GS irresolute function, then it is a binary alpha GS continuous function. And next is strongly binary alpha GS continuous function. A function f from Z to X cross Y is said to be strongly binary alpha GS continuous function if f inverse of U comma B is alpha GS close open in Z for every binary set U comma B in X cross Y. The theorem is every strongly binary alpha GS continuous functions are strongly binary semi-continuous functions. The next theorem is every strongly binary alpha continuous functions are strongly binary alpha GS continuous function. And let x comma y be a binary alpha GS T half space and f from z to x cross y be any function, and the following conditions are equivalent. That is, f is a binary strongly alpha GS continuous function and f is binary continuous function. And the next theorem is let f from z to x cross y be a function, then the following conditions are equivalent. That is, the function f is binary strongly alpha GS continuous function. Second condition is for each z belongs to capital Z and each binary alpha GS open set u comma v with f of z belongs to u comma v, there exists an open set capital P in z such that z belongs to S and f of v is contained in u comma v. And third one is f inverse of u comma v is contained in interior of f inverse of u comma v, where u comma v is binary alpha GS open set. And the fourth one is f inverse of x comma t is closed in Z for every s comma t is binary alpha GS closed set. And the next one is totally binary alpha GS continuous function. The mapping f from z to x comma y is said to be totally binary alpha GS continuous function if f inverse of a comma b is alpha GS close open in z for every binary open set a comma b in x comma y comma m. And the theorem is every strongly binary alpha GS continuous functions are totally binary alpha GS continuous functions. And also every totally binary alpha GS continuous functions are totally binary semi-continuous function. And also the theorem is every totally binary alpha continuous functions are totally binary alpha GS continuous mappings. And these are my references. Thank you.
Yeah, thank you very much. Any
Thank you, sir.
questions? I think we have no questions. Now let's call the next participant as Tamil Selvi. Is she here?
Yes, sir. I'm
Yeah.
there.
She will be presenting on a comparative study and analysis of medical image denosing by using filtering and transform methods. So please present, ma'am. Hello.
Yes, sir. I'm sharing the screen.
Yeah,
Yes, sir.
sure.
Is my screen visible, sir?
Yeah, it's visible and you're
Okay.
audible too.
Okay. Good evening to one and all present over here. Myself as Tamil Selvi, research scholar of Jaipur National University. I am working under Hoshiar Singh, sir, of JNU, and my co-supervisor is a SM Kerner, sir, Professor, Ajinkya D.Y. Patil School of Engineering. The title of my paper of today's presentation is a comparative study and analysis on medical image denoising by using filtering and transform methods. So just this is an overview of my today's presentation. Objectives, introduction, literature review, and different types of noises, denoising methods, and some of the experimental results, and the quality check measures based on the for the images, and conclusion and references. Basically, the main objective of my paper or my research is in today's era, there are various diseases are then and there they are happening. So, but the proper and accurate disease diagnosis is very difficult. So, in order to get a clear denoised image, so that the images, whatever the images we are capturing in any digital machines, we are having some of the noises over there. If we are using some of the methodologies to suppress those noises, then the effect or the efficiency of disease diagnosis will be more appropriate. So the main objective is this, the hybrid techniques, which we can use the finest details present in the medical images. And the second thing is, we have to develop or a technique to improve the image quality metrics. And the third one, the efficient model to reduce the computational time and cost. So basically, what is denoising? So just I'll give a few introduction. Denoising is not just smoothing. It is method of estimating the unknown signal from the available noisy data. So whenever you capture any image in any type of digital machineries we are having nowadays, like CT scan or MRI, I'm just focusing on medical images. And apart from that, we have so many images which can be used in astronomical research also. My focus is clearly towards the medical images. Basically, there are different types of models, noise models available. Two types are there. One is additive noise and multiplicative noise. And additive noise is very easy to remove, whereas multiplicative noise is very
Hello. Hello.
Hello, hello.
I think there's a network glitch.
Yes, yes, I think.
Hello.
Hello.
Sir, just wait. I think this is the network issue.
Yeah, that's what.
Yes, Tamil Selvi.
She has exited the meeting. I think that she'll be rejoining it.
Okay, okay.
Just wait for a couple of minutes and then we can proceed.
Yes, sir.
Let's proceed to the next presentation. We can take her presentation again.
Yes, sir. Yes, sir.
Yeah. Our next presenter is Preeti B. Jinagowda. Is she
Hello,
here?
sir.
Yeah.
Is it audible, sir?
Yeah, you are audible.
Yes.
The presentation is on the topic cubic denomination in graphics.
Is it visible, sir? Screen is visible?
Not yet. I hope it will be visible.
Now is it visible, sir?
No, not yet.
Now, sir?
No.
Okay, sir. I am presenting my paper on cubic domination in graphs.
Yeah, okay.
Here abstract is that.
Okay, kindly. Your screen is not visible, so
No.
kindly. Yeah. So I request you to kindly summarize your findings.
Okay.
Yeah.
Is it okay, sir?
Yeah, it's okay.
Okay. A subset D is a subset of V is a dominating set of graph G if every vertex in V minus D is adjacent to one or more vertices in D. Let G be a graph. A subset D of vertex set of G is said to be cubic dominating set if for every V belong to D there exists U belongs to V minus D such that UV belongs to edge set. And also here one more condition is that summation of V belongs to D, degree of V cube is sum of the U belongs to V minus D into degree of U cube. The minimum cardinality among all cubic dominating sets of the graph G are called cubic domination number. Further, and cubic domination set D is minimal cubic dominating set if no proper subset of D is an cubic dominating set. The set cubic dominating set D with cardinality is called as
cubic dominating set of the graph G. Your introduction. The graphs considered here are finite, undirected, without loops or multiple edges. A graph with P vertices and Q edges is called a PQ graph. The neighborhood of a graph vertex U in V is the set of NU consisting of all vertices V which are adjacent with U. The closed neighborhood is N of U, which is equal to N of U union U. Let S be a set of vertices and here U belongs to S. A vertex V is private neighborhood of U with respect to some set S if N of V intersection of S that is equal to U. The private neighborhood of set of U with respect to S is the set Pn of Us V N of V intersection of S that is equal to here U. If U belongs to private neighborhood of Us and U is an isolated vertex, then U is called an own private neighborhood. Next, let the vertices of degree 1 are called as leaves and the vertices adjacent leaves are called as the support vertices. A set subset of V is a dominating set of G if each vertex in V minus S is adjacent to some vertex in S. The domination number gamma G is the smallest cardinality of a dominating set. A dominating set is said to be minimal if no proper subset of S is a dominating set of G. It is known that maximal independent set of G is a minimal dominating set of G. Next, cubic domination number of standard class of graph. In this section, we calculate the cubic domination number of some standard class of graph such as complete graph, cycle graph, and also path graphs. Their proposition for complete graph Kp, where P is an even integer, then cubic dominating set of complete graph is given by P by 2. For cycle graph, that is denoted by Cp, where P is an even integer, then cubic dominating set of Cp is P divided by 2. For path graph, that is denoted by P subscript P, where P is an even integer, then cubic dominating set of path graph is P by 2. Next proposition is that for any k-regular graph G of even order, cubic dominating set is P divided by 2. Your theorem, for any connected graph satisfying cubic dominating set, that is gamma CZG of is less than or equal to P divided by 2. Further, the upper bound is attained if and only if G has perfect matching with equal distribution of degree of vertices. Next theorem is that let G be a connected graph satisfying cubic dominating set D. If D is minimal cubic dominating set, then V minus D is also a cubic dominating set of G. Your observation is that for a star graph K1 P minus 1, where P is greater than or equal to 4, the cubic dominating set does not exist. Next theorem is that for any connected graph G with maximum degree delta G is less than or equal to P by 2 and cubic dominating set of G is less than or equal to P minus delta G. Next theorem is that let G equal to H composition K1 where H is any connected graph of even order, then cubic dominating set GO is P divided by 2. Next theorem is that a dominating set D of a graph G is minimal cubic dominating set if and only if it satisfies the following conditions. Those are private neighborhood of V of D is does not equal to null set for every V belongs to D, and summation of V belongs to D, degree of V cube is equal to sum of U belongs to V minus D into degree of U cube. Next theorem is that let G be any connected graph having minimum cubic dominating set D, then G is minimal cubic dominating set. Next result is that let G be a simple connected graph with P vertices and Q edges with cubic dominating set equal to K for some positive integer K, then cubic dominating set of G is greater than or equal to 2 kp divided by square root of p into m1 of g, where m1 of g is the first Zagreb index. Next lemma, let a1, a2, etc. an and b1, b2, etc. bn be non-negative integers, then summation r equal to 1 to n, ai to the power r is greater than or equal to n to the power 1 minus r into summation I equal to 1 to n bi to the power r. Next lemma is that let a1, a2, etc. an and b2, bn be non-negative integers, then summation from I equal to 1 to n ai to the power r plus 1 divided by bi to the power r is greater than or equal to summation from I equal to 1 to n into ai whole to the power r plus 1, that whole divided by summation from I to n bi whole to the power r. Next lemma is that let a1, a2, etc. an and b1, b2, etc. bn be non-negative integers, then summation from I equal to 1 to n bi whole to the power alpha minus 1, summation from I to 1, I equal to 1 to n bi into ai to the power alpha is greater than or equal to summation from I equal to 1 to n ai into bi whole to the power alpha. Next theorem, let G be a simple connected graph with p vertices and q edges with cubic dominating graph G, which is equal to k, where k is the some positive integer. Cubic dominating set is less than or equal to alpha n into delta minus delta whole to the power square 2p into p minus 1, where alpha n is given by here n into n divided by 2 into 1 minus 1 divided by n into n by 2. Next theorem is that let G be a simple connected graph with p vertices and q edges, then with your cubic dominating graph is equal to k, then here cubic dominating graph is less than or equal to square root of delta plus here that is a dominating number into 2p minus first Zagreb index, that the whole divided by delta into delta. The applicability of the cubic dominating set in QSPR analysis. In this section, we examine the applicability of the cubic dominating set with the set of 67 alkanes. For this, we consider the physical properties like boiling points, molar volumes, molar refraction, heats of vaporization, surface tension, melting points, eccentric factor of octane isomers. And here we have the linear model and also quadratic model and logarithmic model. Okay, these are the by using the sum analysis. Here we have the logarithmic model and the quadratic model. Next, linear model. These are the sum references. Thank you.
Thank you. Thank you so much.
Thank you, sir.
Any question from the audience? No. So the next presenter is Simran Narula. Simran, are you
Yes,
there?
sir. Yes, sir.
Yes, sir. So now you can present your work.
Yes, sir. So is my screen visible?
Yes, it's visible.
So, good evening, everyone. I'm Simran Narula from MS Applied Mathematics, Amity University, Noida. And today I'm presenting the paper on topic feature selection using nature-inspired optimization techniques. This is the overview of the paper. Now, first of all, the topic says feature selection using nature-inspired optimization techniques. So what is feature selection? Feature selection is the process of reducing the number of input variables when developing a predictive model. It is desirable to reduce the number of input variables to both reduce the computation cost of the model and in some cases to improve the performance of the model. Statistical based feature selection methods evaluating the relationship between each input variable and the target variable using stats and selecting those input variables that have the strongest relationship with the target variable. So these methods can be fast and effective, although the choice of the statistical measures depends on the data type of both the input and output variables. So why feature selection is important and how we can implement the feature selection. Feature selection is a process that chooses a subset of features from the original features so that the feature space is optimally reduced according to a certain criterion. These methods are generally used while doing the pre-processing step. These methods select features from the dataset irrespective of the use of any machine learning algorithm. So why the feature selection is important in a model? In terms of computational, they are very fast and inexpensive and are very good for removing duplicated, correlated, redundant features, but these methods do not remove multi-clonality. Selection of feature is evaluated individually, which can sometimes help when features are in isolation, but will lag when a combination of features can lead to increase in the overall performance of the model. It helps to reduce the dimensionality of the feature space, to speed up a learning algorithm, and to improve the accuracy of the classification model. Now, how we can remove the features, or we can select the features from a subset of features. One of the method that I will use in the paper is nature-inspired optimization techniques. Now, what are the nature-inspired optimization techniques? Nature-inspired optimization techniques are the set of algorithms that draw their inspiration from natural phenomena such as biological systems, swarm intelligence, physical and chemical-based features. Nature-inspired optimization algorithms are the group of unique problem-solving methodologies and approaches that are inspired by the natural processes. These algorithms are inspired by the social structure and foraging patterns found in nature. Nature-inspired optimization algorithms are becoming more popular and are regarded as efficient since they find a reasonable solution to optimization problems in a fair amount of computational time. Now, what is the objective of my study? As we know, in this 21st century, misdiagnosis of illness like cancer, heart disease, etc., is the leading cause of mortality for people globally. In the medical sector, disease diagnosis is a difficult undertaking that frequently increases the fatality rate. A number of researchers have lately applied the use of data mining, machine learning, and deep learning approaches in healthcare to forecast the illness, but still, the capability to accurately detect diseases is important in the area of medical diagnosis. So, the accuracy of illness diagnosis is influenced by the number of important parameters, included feature selection. So, our objective of the study includes research and create practical strategies for choosing the most helpful and relevant features from huge data sets, investigate the application of nature-inspired algorithms and how they are used in feature selection, address the difficulties associated with illness identification. The study also attempts to optimize the selection of disease-specific variable and enhance the precision, sensitivity, and specificity of the final diagnosis by using nature-inspired algorithms. So now what the methodology I have used is, in this study, I have created a model that is HBA-KNN feature selection and disease detection method. Initially, as we see in the block diagram below, initially I take the input data, which I have considered for a specific data set. Then I have given this data to the pre-processing phase, which includes the quantile normalization method and missing data imputation method. After that, I have used proposed feature selection methods that helps to select the suitable features utilizing the Congress coefficient and Kumar-Hasselbalch similarity. Finally, additional features are chosen from the previously chosen characteristics, and disease prediction is carried out using KNN, which was trained using the honey badger algorithm, that is a nature-inspired optimization techniques. This is the methodology I have used. Now, I have used honey badger algorithm, which will be used to train the KNN algorithm. So mainly, what is the honey badger general biology? Honey badger is a mammal with black and white fluffy fur, known for its fearless nature. This dog-sized fearless forager preys 60 different species, including the dangerous snakes. It is an intelligent animal able to use tools, and it loves honey. It prefers to stay solitary in self-dug holes and meet the other badgers only to mate. So how this algorithm is the foraging behavior of the honey badger. So how it forage? A honey badger locates its prey by walking slowly, continuously using its spelling mouse skills. It starts to determine the approximate location of the prey through digging and ultimately catching it. In a day, it can dig as many as 50 holes in a radius of 40 kilometers or more. Honey badger like honey, but it is not good in locating beehives. On the other hand, honey guide, a bird, can locate the hives but cannot get honey. So this phenomenal led a relationship between the two, where the bird leads the badger to beehives and helps it open hives using its long claws. Then both enjoy the honey. So what is the HBA procedure? The it's what's its inspiration. Honey badger algorithm imitates the foraging behavior of honey badger. For locating food resource, the honey badger either smells, digs, or follow honey guide bird as shown in the block diagram below. We call the first phase as digging mode and the second phase is honey mode. In the prior mode, it uses its smelling ability to approximate prey location when reaching there. It moves around the prey to select the appropriate place for digging and catching the prey. In later mode, honey badger takes the guide of honey guide bird to directly locate the hive. So this is the mathematical model which I will explain in a short manner. HBA is divided into two phases where it is a digging phase and honey phase. The algorithm steps includes, first we will starts the population, we will have the population of the candidate solutions. Then first step is initializing phase, where we have initialized a number of honey badgers and the respective positions. Next one is defining intensity. Intensity is related to the concentration strength of the prey, that is the distance between the prey and the honey badger, where I is the smell intensity of the prey. Obviously, if the smell is high, the motion will be fast and vice versa, which is given by the inverse square law as shown in below figure, and it is defined by the equation 2. Next step is update density factor. The density factor controls time varying randomizations to ensure smooth transition from exploration to exploitation. Then escaping from local optimum. This step and the next two steps are used to escape from local optimum regions. That is, the proposed algorithm uses a flag F which alters the search direction for availing high opportunities for agents to scan the search space rigorously. Then updating the agent positions as discussed earlier. HB position update process is divided into two parts again, which is as a digging phase and honey phase. In the digging phase, a honey badger performs action similar to the chidoid shape as shown in the figure. The chidoid motion is given by equation number 4, where X prey is the position of the prey, beta is the ability of honey badger to get food, F is the flag already mentioned, R3, R4, R5 are the different numbers. And equation 5 represents how F works. F is the flags that alters the search direction. So in the summary, in the digging phase, a honey badger heavily relies on the smell intensity of I, distance between the badger, and time varying search influence. Then honey phase, the case when a honey badger follows honey guide bird to reach beehive is given by equation number 6, where x new is the new position of the honey badger and f and alpha are determined using equation 5 and equation 3. So it can be observed that a honey badger performs search close to prey location found so far based on distance information DI. At this stage, the search is influenced by search behavior. Moreover, honey badger may find disturbance F. This is the pseudocode that I have applied. Now, why I have chosen HB as an algorithm to in my model to detect diseases? Because of the four reasons. Because of the exploitation behavior of the honey badger is effectively ensured with the help of an intensity parameter which guides population individuals to already identified promising regions. Then the density factor is used for dynamic time varying randomization to ensure smooth transition from exploration to exploitation. Third reason is HBA uses flag as does not allow population candidates trapping in local regions. Then digging and honey phase maintain constructive impact on solution update process by balancing exploration and exploitation properties of search mechanism. Now, what I have used the proposed technique for feature selection and disease detection. I explained in the block diagram previously. This is the procedure. First step, I have get the input data, a medical data from a disease data set C. Then I have given this data to the data pre-processing, because data must first be cleaned, transformed, and prepared as a part of data pre-processing, which is a crucial step in data analysis and machine learning before utilizing in a model or analysis. So therefore, next step includes the pre-processing of the input data using quantile normalization and missing data imputation. The pre-processing methods are used to remove the redundant data from the input data. So in the pre-processing, I have used two methods, quantile normalization and missing data imputation. So what is quantile normalization? In this quantile normalization, the first step is to rank the input data based on the magnitude values, then compute the average values of the input data with the same rank. After that, applying the values of input data occupying that specific rank with the average value. Then the final step is to rearrange the input data in the original order. So then for normalization, the input data C, A, K into N is subjected to quantile normalization, and then the result is we have saved it as a Q and K into N. And next is missing data imputation, because in our data there are some missing values. So efficient method for handling missing values in the data set is by using missing data imputation. So there are several methods to for missing data imputation, such as mean imputation, median imputation, mode imputation, regression imputation, and multiple imputation. So we can choose these methods according to what of type of data we have used. So after that, step third includes, after the pre-processed data, the data which simply needs meaningful features, because not all the features are essential for predicting the disease. So we will first select the features using the already proposed Congress coefficient and Kumar-Husebrecht similarity. So in order to choose the features, now we will deliver the data to the Congress coefficient method, then to the Kumar-Husebrecht similarity. So what is congruence coefficient? The congruence coefficient is by comparing the candidate feature with the target values. The congruence coefficient determine how similar two configurations are. So it improves the model capacity for prediction. The congruence coefficient is expressed by this equation Cm. Then the after that, first there are n features. After applying the congruence coefficient, we are left with the d features. After that, we will next step should be the Kumar-Husebrecht similarity is applied after choosing the best features. So Kumar-Husebrecht similarity is given by the formula Km, where R denotes the candidate feature, S denotes the target values. After applying this formula, we are left with the top E features with the largest values are chosen as the best features. Now we are left with the E features. After that, I have created a model algorithm, that is KNN HBA. So what is KNN? To identify medical issues, a number of deep learning techniques are often applied. In this work, further features are selected and disease is predicted using KNN, that is K nearest neighbors, which is trained using the honey badger algorithm method. In this instance, the KNN model select the input Z, K into E. E is which the features we have selected after giving the data to congruence coefficient and Kumar-Husebrecht similarity to forecast the illness. So K nearest neighbor, sometimes known as KNN, is a non-parametric classification technique used in machine learning. So it has mainly two parts, a training set and a testing set. A training set with known labels, a testing set with unknown labels is used. So, and the parameter K that defines how many neighbors you want into account when generating a prediction make up the structure of KNN. So KNN in feature, how we can use KNN in feature selection and disease prediction. So as shown in the figure below, we have taken a medical data set. Then after medical data set, we have done data pre-processing, which I have already explained. Then we will select the features using KNN. And then we split the data into a training and testing set, and we will train the data using HBA. This is already explained as we have shown in the block diagram below. Now, how we will we can train the KNN using Honey-Badger algorithm. Honey-Badger algorithm is utilized to train the KNN that was employed in this study based on the behavior of the honey badger animal, as explained below. The honey badger algorithm is a metaholistic optimization method, so it will help to train KNN. The below figure illustrates the general procedure of training KNN using the honey badger algorithm. That is, first we will initialize the population, then evaluate the fitness, then select best solutions, then apply honey badger operators that I have already explained before, that in the mathematical model of honey badger, then evaluate the new solutions and select best solution. Those best solutions are the best features. Overall, training a KNN using the honey badger entails the process that chooses and adjusts potential solutions depending on how well they perform. Now, what are the results and discussion? The experimental setup for the study on feature selection using nature-inspired algorithms for the KNN for disease prediction entails gathering and pre-processing data using feature selection algorithm, training KNN model, and assessing the performance of the models using various metrics. And this presented model is implemented using the MATLAB program. Dataset used, I have used a breast cancer Wisconsin dataset that includes 569 cases in the datasets and includes 30 features including radius, texture, parameter, area, smoothness, compactness, and the diagnosis, which can be either malignant, that is cancerous, or benign, that is non-cancerous, is a target variable. The dataset is labeled with 357 cases being classified as benign and 212 as cancer. And the performance measure I have used are the accuracy, sensitivity, and specificity. This I have explained. What is the accuracy? Accuracy in a disease prediction and model denotes the ratio of the model accurate prediction to its overall prediction, and its formula is given by true positive plus true negative upon true positive plus false positive plus true negative plus false negative. Sensitivity is referred as a true positive rate. Specificity is referred as the negative cases, that the false positive rate. True positive, false positive, true negatives, and false negatives are the number of true positives are the number of positively predicted cases in which the model was accurate in predicting the presence of the illness. False positive is the model predict a positive result even if the patient does not have the condition. And true negative are the number of correctly predicted negative instances, and false negative are the number of situations where the model predicts that a patient does not have the disease despite the fact that the patient have the disease. So I have comparative methods in this research. The HBA KNN is assessed with the most commonly used nature-inspired algorithm, that is the particle swarm optimization. And the comparative analysis I have done regarding the number of iterations, number of runs, training data, and k-value. First, I have done analysis regards to the number of iterations. So as we see that in all the cases, PSO outperforms the HBA. When I have done analysis regards to the number of runs, that is, I have done with the first with the 5 runs, then 10 runs, then so on up to the 30 runs. In this case, we can see that the HBA is does not outperform, by the way PSO is outperforming the HBA. Then when I have done analysis regards to the training data, then the HB and PSO at the 90, when we have divided the data to the 90-10 ratio, that is 90% training, then both the algorithms, the results of both the algorithms are the same. Then I have done analysis regards to the k value. From k value 5 to 9.
Conclude it.
Excuse me.
Yeah, kindly conclude your presentation.
Yeah, so this study presents the HB-KNN approach, and we have seen that when we have done this on the MATLAB program, then we have received a possible precision of 0.97, sensitivity of 0.94, and specificity of 0.99. In conclusion, we have that illness detection has shown encouraging results when using the HBA for feature selection in KNN. These methods can enhance the KNN algorithm performance and boost its accuracy, sensitivity, and specificity. But when we compare it with the particle swarm optimization approach, then we have seen that the PSO approach outperformed the HBA-based approach in terms of accuracy, sensitivity, and specificity. So in future aspects, we can see that we can develop a better version of HBA because the results shown that is not superior than PSO. Alone, it is superior, but when we compared with it PSO, it is not superior. So we can develop a better version of HBA. However, the performance of the proposed technique is assessed using only using precision, sensitivity, and specificity. So in future work, we can assessed it using many performance indicators. More matrices will be considered in the future. And these are the references. Thank you so much.
Yeah, thank you very much. Now the house is open for questions. Are there any questions? Okay, thank you. I request the presenters to kindly present in the stipulated time. Kindly do not take more than 4 minutes for presentation and 1 minute for question answer. Now I request Pragya Singh to present the paper. Pragya Singh, is she here? Pragya Singh. Okay. Jugal Kishore Sharma.
Hello, am I audible?
Yeah, you are audible.
Let me explain the
Yeah. So she will be presenting on the topic strategic human resource enhancing performance with Six Sigma approach. Yeah, kindly present it. Hello.
Yes, sir. Wait a
Yeah.
minute, sir.
Okay.
I'm opening the slide. Sir, is it visible?
It's not visible.
Is it visible now?
Yeah, it's visible.
Okay. So first of all, I would like to extend my gratitude to all the organizers for giving me this opportunity to be a part of this global conference. So my topic is strategic human resource management, enhancing performance with Six Sigma. Now, coming to the first slide, abstract. So Six Sigma has basically been widely adopted by many different types of organizations. So these organizations could serve in a service sector as well as in a manufacturing sector. Some of the examples are Infosys, TCS, Wipro, Ford, Motorola, which have successfully implemented Six Sigma technique in their business process. Now, this paper first reviewed the current literature on Six Sigma and then performed a critical analysis of Six Sigma in the light of management literature. Six Sigma is best defined as a new approach to quality management. So overall, Six Sigma focuses on producing a quality product and services in order to achieve the organizational goal. This study laid a foundation for future research on Six Sigma. Six Sigma is strongly supported by the theoretical notion of zero defects. As we all know that Six Sigma is basically focuses on reducing the variations and eliminating the defects in products and services and providing the quality product and services to the customers. The Six Sigma problem solving methodology is DMARC, has been one of several techniques and used by the organizations. Six Sigma deployment in HR transforms typical HR practices with a proactive approach, where the in proactive approach the problem is problem is fixed before its occurrence. The research develops various framework for Six Sigma deployment in HR and provides case studies of successful Six Sigma deployment in various areas of HR. Now moving to the next slide, its introduction. Human resource is an important business function as it expedites the shaping of organizational culture, elevates employee engagement, and boosting managerial effectiveness. So, as it is tasked with maximizing employee productivity and protecting the company from any issues that may arise within the workforce. So, as a result, organizations must develop the foundational HR capabilities for efficient service delivery. In order to improve the HR's productivity and meet employee expectations more accurately and efficiently, HR processes needs to be improvised, optimized, and by implementing the different techniques. However, HR faces numerous difficulties in a variety of areas. It could be high employee attrition rate, it could be low employee engagement, etc. So by the deployment of Six Sigma, these problems could be fixed. So this research basically explores the Six Sigma deployments in the HR functions and provides a case study of its successful deployment. Now coming to the next slide. So let us understand what is Six Sigma. So Six Sigma is basically it got into existence in 1980s. First, it was first implemented by Motorola, and the father of Six Sigma is Bill Smith. So Six Sigma has been developed and honed over the years into what is now recognized as one of the leading methodological methods for enhancing customer satisfaction and corporate operations. It is the Six Sigma is basically a systematic methodological approach in which the statistical data is being concluded, and it is a method, problem-solving method, in which the variation is identified and reduced, and at the same time the defects are eliminated. Now moving to the next slide. Six Sigma, here we can see a histogram. At the extreme left hand side there is a low specification limit, and on the right hand side there is a upper specification limit. As we can see that an organizations try to achieve the Six Sigma state so that they can achieve the level where they can produce a product with 99.997% defect-free products. Now coming to the next slide. Methodologies. Here we are going to discuss about the DMAP methodology or Six Sigma. In that, D stands for define, N stands for measure, and A for analyze, I for improve, and C for control. So define. In this stage, in this step, the problem is being identified, what output to be improved, customers and process associated with the problem. In case of measure, output variables are identified where the improvement measures need to be taken. In analysis step, here the key process input variables are identified to find the root cause of the defects. In case of improve, the implementation of Six Sigma technique is being done. In case of control, input variables are controlled by providing training and all. Now coming to the next slide. Six Sigma organization structure. In order to implement the Six Sigma, and proper organizational structure is required with different roles. These roles will be performed by Six Sigma professionals referred to as yellow belts, green belts, black belts. Here we can see a pyramid. At the top there is a champions or the sponsors. They are the basically they are the leaders of the organization who set the goals for the organization, goals and objectives of the organization, and they also provide the resources to implement the Six Sigma techniques. Now coming to the master black belts, they are the experts who assist the black belts, and also they advise the champions or the sponsors. They actually work as a mediator. Now coming to the black belts, they are the lead projects mentors. Basically they are the one who implement the complicated Six Sigma projects in an organization. Now talking about the green belts, they are the team members who implement the Six Sigma simple projects or which are not that complicated, they work on such type of projects in an organization. Talking about yellow belt team members are those that which they are sort of a helping team members for the black belt and the green belt. Now coming to the next slide. Benefits of Six Sigma methodology. First is profitability. Six Sigma implementation of Six Sigma helps in increasing the profitability of the organization by reducing the variations and defects in the products and services. Customer requirements. Six Sigma basically focuses on producing the quality product by fulfilling the customer's demand. Now, efficiency and effectiveness. So Six Sigma helps in helps the business organization or business process to work efficiently and effectively. Empower employees. Basically, Six Sigma employs the shift from control-oriented approach to empowerment-oriented development activities. Competitive advantage. Six Sigma implementation basically helps in attaining the sustainable competitive advantage. Database decision. So it is a systematic approach and approach of database decisions. Now coming to the next slide. Six Sigma deployment in HR functions by engineering company. So here we are going to this research is basically based on the implementation of Six Sigma technique in HR function. So here we are, in this case study, an engineering company is taken into consideration, which works in 20 different locations where 8,000 employees were, people are employed. Previously, before the implementation of Six Sigma technique, the HR function was considered as reactive, unorganized, overstaffed, and unprofessional, rendering poor, slow, and inefficient services. But after the implementation of Six Sigma Six Sigma in the HR domain, the enhancement of HR processes and achieve the a strategic objective of right people in the right place at the right time at the right cost. The primary objective were develop and implement HR processes and measure of performance with the focus on complete internal customer satisfaction. Six Sigma deployment in HR function by engineering company continued. Basically, to analyze the output variables which is being considered, input variables which is being considered here is rewarding resourcing, communication, and development. So the company achieved busted after the implementation of Six Sigma. The company global engineering company achieved the busted turnover with 15% fewer people with an overhead cost reduction, and for the first time an annual employee bonus was declared. So HR system now transform problems into preventive actions that minimize the likelihood of the reoccurrence of that particular problem. So HR employees ideas moved from being compliant to committed employees. So the implementation of Six Sigma made them more engaged toward the organization. Improved processes resulted in cost saving due to better service quality and reduction in throughput time, defect, and rework. The cost of HR function per employee has also been reduced by 34% in 18 months with the same or better service provided. Six Sigma deployment in HR, a partner in strategy, execution, and synchronization. Six Sigma, basically, the main aim of the human resource synchronization. Here, the organizational goal and the technical competency and the organizational culture is being linked by the Six Sigma implement by the team in order to achieve the organizational goal. Six Sigma implementation enables the organization to develop or carry out a strategic breakthrough while successfully managing continuous improvement performance as a part of total quality system. In this, the top management, the middle management, and the project managers are linked up. The top management provides the resources and the support to the middle management and the project managers to implement the Six Sigma properly. Six Sigma deployment in HR managerial implications. Six Sigma is basically a data-driven improvement methodology. So in order to optimize the process output, Six Sigma places more emphasis on defect prevention than defect discovery by eliminating the defects and reducing the variations. The implementation of Six Sigma in HR aids in re-engineering of HR processes. So Six Sigma methodologies would be more suitable for a thorough revamp of HR procedures because they place an emphasis on entire process. With the use of simple and effective statistical techniques, firms can employ the potent Six Sigma strategy to constantly improve HR processes, effectiveness, and efficiency. Less than 50 before the COVID outbreak, less than 50% of the organizations had a remote working plan. So after the COVID outbreak, majority of the organization shifted towards toward the remote working plan. So when they implemented remote working plan, many problems arise. So in order to overcome those problems, Six Sigma implementation worked as a miracles for them. So Six Sigma implementation. So in order to implement the Six Sigma, an organization must have a project. So while working on project under the direction of this black belt, which we have discussed earlier, HR professionals may advise in their certification, learn how to use the tools and win over other stakeholders at the same time because HR would be swiftly resolving their issues. As a result, the black belt is assisting HR solving the issues while HR is also receiving training and pursuing certification. The Six Sigma certification gives HR professionals a firm grasp of Six Sigma principles and equips them to contribute significantly to Six Sigma teams. With their expertise in change management, these Six Sigma certified individuals also guarantee the team's efficiency and help establish the proper Six Sigma culture. Six Sigma project failure in HR. So the first point is it happens because of the lack of the top management. Top management and Six Sigma project requires leadership support to secure funding, overcome challenges, and assess the team's improvements, which embed themselves in the organization's culture and become an indelible way of conducting business. Now, the second point is erratic team leadership. Ineffective team leaders are to blame for the failure of the Six Sigma programs. The experienced black belt who leads Six Sigma project teams typically ensures that they stay on task and make progress. Now, the third point is no connection to financial success. Six Sigma initiatives that concentrate on lowering costs or boosting effectiveness with a favorable financial impact receive more attention, command more respect, and receive more backing from senior management than activities that are not specifically related to financial success. Now, coming to the next slide. Conclusion. So, this study is distinctive because it conducts thorough investigation of a case study to highlight the effective application of Six Sigma in the HR function. The company's Six Sigma implementation successfully controlled and resolved the different HR difficulties it encountered. And the use of Six Sigma in the HR function changes the total workflow and develop new capabilities for boosting business performance. Thank you. These are the references.
Yeah, thank you. Thank you very much. Any questions? The floor is open for question. Okay. Now I request Ram Vilas Dadhich ji to kindly present the paper. Is he available here?
Yes, sir.
Yeah.
Yes, sir.
The title of the presentation is Heavy Metal Toxicity in the Agricultural Land Near Industrial Area. Kindly proceed, sir.
Sir, I am unable to present my screen.
Okay. Any technical glitch, sir?
Yes.
Okay. So in that case, sir, just read the findings and conclusion, because
Yes,
it will
yes.
be very
Okay,
lengthy.
okay, sir.
Yeah.
First of all, I express my gratitude to the dignitaries for giving such global platform to present my paper.
Hello.
Yeah.
Yes, sir.
Rambala
Please
Yes, yes,
continue.
sir. Yes, sir.
And chair will also the website ID is 1029.
Yes.
Serial number is 14.
Hey. Am I audible?
Yeah, you are audible,
Yes,
sir.
sir. Heavy metals in the environment at certain quantities are known to be harmful to human and animal health. High concentration of dangerous heavy metals can be found in the soil around many factories because of the untreated liquid effluents and that are dumped there. The presence of heavy metal in quantity far above their background level in soil is indicative of soil contamination. The heavy metal pollutant come from a wide variety of places. These places includes air, water, and soil. Soil components like clay and organic matter can form semi-permanent bond with these elements, preventing them from leaching into surface or groundwater or being taken up by the plants. Soil pollution means the presence of chemicals or substance in the soil at higher than tolerable concentration, affecting non-targeted life form, which occur by anthropogenic activity and by natural processes. Soil pollution is not measured or observed directly, so it is hidden danger and must be continuously watched. The changing agrochemical and industrial development, urbanization, industrialization, mining, and chemicals used in agriculture. In urban area, the soil has been used for dumping solids and liquid waste with the wrong notion that the pollutant being out of sight and left in the ground will not cause any health problem and will disappear after some time without having any impact on the environment. The primary source of soil pollution is anthropogenically accumulated contaminated to the level of great concern. The detection of soil pollutant become difficult and expensive due to the diversity and transformation of organic compounds. The accumulation of pollutant like organic compounds, heavy metals, decreases crop production and enters the food chain due to bioaccumulation and biomagnification. Also, the excess presence of these metals pollute surface and groundwater. The crust of Earth is mostly composed of metal. As metal-based businesses grew, the environment was polluted and people and the ecosystem were exposed to the hazards level, possessing a possible health concern to the both human and wildlife. For mineral elements, plants rely on the soil. Mineral-rich soil are a rich source of most critical components are broken down into major elements such as calcium and magnesium, as well as trace elements like copper, manganese, boron, and iodine, as well as micronutrients such as phosphorus and sulfur. Plants and animals need all of these to thrive and stay healthy. Animals that eat the plant that contain these toxic heavy metals is another problem. Trace elements contamination of soil is now universal in urban area. Soil which contain high concentration of arsenic and cadmium occur naturally in a few places, and soil with high level of lead sometimes occur in area where ore of lead are present. Among the various types of contaminant, heavy pollution caused by heavy metals poses a serious threat to the humanity. Metals which have density greater than 5 or mass number greater than 23 are termed as heavy metals. Heavy metals are non-biodegradable in nature, form stable complexes and cause undesirable effects. Trace quantity of certain heavy metals such as chromium, copper, manganese, nickel, and zinc are required for the normal metabolic functioning of the living system, but when their concentration exceeds their certain critical limit, they become toxic and cause various health hazards. The presence of such potentially hazardous heavy metal in water usually affect its potability and palatability. The excessive use of pesticide and fertilizers in agriculture is also a source of heavy metal mixed in soil. As the heavy metal are non-biodegradable, their accumulation in living bodies beyond certain limits causes ill health effect. The heavy metal accumulation in the body leads to fatal disease like anemia, nephritis, renal tumor, increased blood pressure, cardiovascular disease, and eyelid edema. Many authors have reported that heavy metals in the body can cause even cancer and malfunction of different body system, the hormones synthesis and metabolism are also affected by heavy metals. So there are basically two different kind of resource of heavy metal: anthropogenic sources like electroplating, steel industry, smelting, fly ash, mining, batteries, tannery industry, distilleries, surgical instruments, and other sources. Natural resources are weathering of minerals, erosions and volcanic activities, forest fire, biogenic sources, particles released by vegetations, and other resources. The natural channels are erosion, weathering, anthropogenic channels, including industrial, agriculture, medical, metallurgy. Human activities are much more responsible for soil pollution. Ores processing is the beginning of heavy metal contamination. Heavy metals, natural sources from weathering and leaching, are of little consideration. Toxic metal, due to their bioaccumulation in living tissues and their harmful effect on the environment, is a serious concern. The heavy metal mixed with soil and water slowly by industries like metal processing, paints, pigments, pulp, paper, plastic, rubber, textile, thermal, power plants, and mining. Study area. It has been hypothesized that soil sample from the industrial area in Borunda region in Bilada Tehsil of Jodhpur district in Rajasthan contain a high active concentration of heavy metal. As being of industrial area, the concentration of these elements in the soil undermine the agricultural yield and health of nearby living population. Therefore, it is important to determine the concentration of heavy metals in the soil from the Borunda region of Jodhpur. Conclusion. Mineral-rich soil is necessary for the proper growth of plants. Abundance of selected mineral increases fertility of soil, which in turn increases agricultural yield. But when these metals are present in excessive amount, then they are harmful and needs to be discarded properly instead of being directly dumped into the soil. The problem needs immediate attention so as to curb it timely. Thank you so much for listening to me. Thank you, sir.
Yeah, thank you very much, sir. Any questions? Okay. Now I would like to call Arun Kumar Sriram Pandey.
Yes, sir.
Yeah. Your topic is process parameter optimization of abrasive water jet machining and hot abrasive jet machining process using RAW algorithms.
Yes, sir.
Kindly present, sir.
Sir, I am unable to share my complete screen. While I am sharing, it is not open.
Okay. You just click on the present now icon.
Yes, sir. I have clicked over there.
Okay. So you just brief out within the 4 to 5 minute your work.
Just discuss your findings. I mean, the reading will be very monotonous. So please discuss the findings.
Okay, sir. This is Arun Kumar Pandey, MTech student from Sambhunath Institute of Engineering and Technology. Currently, I am doing my MTech under the guidance of Dr. Ansuman Srivastava. My topic for presentation is process parameter optimization of abrasive water jet machining and hot abrasive jet machining processes using RAW algorithm. So basically in this research work, 3 newly developed meta heuristic algorithm developed by R.V. Rao is presented. The RAW algorithm is a meta heuristic optimization algorithm that does not need to define any algorithmic specific parameter and is also metaphorless. The maximum number of function evaluation and population size are the only 2 simple controlling parameters which need to be defined for the optimization of any algorithm, any problems. The RAW algorithms proposed by R.V. Rao in 2020 have mainly 3 variants named RAW1, RAW2, RAW3 algorithms. All these 3 variants of the algorithm utilizes both best and worst solution from the previous iteration to produce introduce randomness among the candidate to effectively convert the given problem to an optimal solution. In this research, research study work, two different case studies. First one was on abrasive water jet machining, and second one was on hot abrasive jet machining performed. From abrasive water jet machining, result obtained were that the result objective function were minimization of taper angle and maximization of curve top width. The results obtained from the taper angle and result obtained from the three variants of the Rao algorithm for taper angle and curve top width were superior than biogeography based optimization, simulated annealing, Firefly algorithm, PSO particle swarm optimization, BH, and CSA. It was also observed that the number of iterations required for the Rao algorithm to converge to optimal solution was very less as compared to other optimization technique. Rao algorithms mainly needed 2 to 6 iterations. For the curve top width, it needed 2 iterations to get the optimum value, while for taper angle, Rao algorithm needed 3 iterations, Rao 2 algorithm needed 5 iterations, and Rao 3 algorithms needed 5 iterations to get the optimum value. While other advanced optimization techniques like BBO and PSO, GA, they all needed more iterations than the Rao algorithms. Also, the CPU runtime required for the Rao algorithms were less in comparison to that of Jaya algorithm and BBO algorithm. CPU runtime required for taper angle for Rao algorithms were 0.1158, 0.288, 0.3319 for Rao 1, Rao 2, and Rao 3 respectively. While for Jaya algorithm, it was 0.4166 seconds, and BBO, it was 1.12 seconds. And CPU runtime for curve top width using Rao 1 algorithm, Rao 2 algorithm, and Rao 3 algorithm is 0.2617, 0.3854, and 0.3948 seconds respectively. It was 0.417 and 0.5112 using BBO. The CPU runtime required by all these algorithms were almost similar to each other, but in general overview, Rao algorithms needed less CPU runtime as compared to Jaya and BBO. In second case study, which presents the process parameter optimization of hot abrasive jet machining process, we have considered 3 objective functions, MRR, SR, and taper angle. The maximum value of MRR obtained from the Rao algorithms were 0.028 gram per minute. Surface roughness was 0.8904 micrometer, and taper angle was 20.007 degree from the 3 variants of the Rao algorithm. These results are for the single objective optimization. For the multi-objective optimization, result obtained from the 3 variants of the Rao algorithm were better than the genetic algorithm, but competitive with response surface methodology. While considering equal weight for all the objective, that is 1/3 for MRR, 1/3 for SR, 1/3 for TA. The value of MRR obtained from the 3 variants of the Rao algorithm was 0.0208 gram per minute, while from GA algorithm, it was genetic algorithm, it was 0.0164 gram per minute. And surface roughness is also improved from the Rao algorithms in comparison to genetic algorithm, that is 0.9297 micrometer from 1.2057 micrometer. Also, taper angle is also improved from the Rao algorithm in comparison to genetic algorithm. Minimum taper angle obtained from the genetic algorithm was 27.6 degree, and from the Rao algorithm it is 21.04 degree. So in overall conclusion, the result obtained from the 3 variants of the Rao algorithms were better than other advanced optimization techniques like PSO, FA, SA, CSA, BS, and Jaya algorithms. Thank you, sir. Any query?
Yeah, the house is open for questions. Anyone who's interested in questions or have any queries regarding it? Now let's call Ashwani B.
Thank you.
Okay, thank you very much.
Good evening, everyone.
Good evening, ma'am. The topic registered for you is perfect Hop domination number of P regular graph for even degree verticals. Yeah, your screen is visible, ma'am, and your audible.
Yeah, my topic is perfect Hop domination number of P regular graphs of even degree vertices. So I'm going to take REN be a P regular graph of even degree. By P regular graph, we mean a graph with vertices whose degrees are P. And here we are going to discuss about the perfect Hop domination number of P regular graphs of even degree. That is, we are going to take P regular graphs of even degrees alone. And by perfect Hop domination set, we mean we are going to take a subset SPH of the vertex set. And if we take a vertex, every vertex in V difference SPH, there will exactly exist one vertex in SPH such that the distance between those two vertices U and V will be 2. And the perfect Hop dominating set with the smallest cardinality is called as the perfect Hop domination number of the P regular graphs, and we are denoting it by gamma pH. So in this paper we are going to discuss about perfect Hop domination number of P regular graphs of even degree. And my first theorem is for an even degree P regular graph with n equal to P plus 2, the perfect Hop domination number will be n by 2. So here we are going to take the vertex set as V1, V2, etc. Vp plus 2. That is the last vertex will be P plus 2th vertex. Here the vertices V1 and Vp by 2 plus 2 will separate our vertex set of our graphs equally. So here we are going to take our perfect Hop domination set as V1, V2, etc. Vp by 2 plus 1. Since Vp by 2 plus 2 is perfectly Hop dominated by V1 and Vp by 2 plus 3 will be perfectly Hop dominating by V2. Like this, Vp plus 2 will be perfectly Hop dominated by Vp by 2 plus 1. Now we have to prove the minimality of the set. So to prove the minimality of the set, we are going to take a subset of SPH, and if we take any subset of SPH, it will not perfectly Hop dominate any one of the set in V minus SPH. Therefore, SPH the chosen SPH will be the minimal one. Therefore, our Hop domination number is P by 2 plus 1, which is equal to N by 2. See in this example, so we have taken P equal to 6 and N equal to P by 2, that is N equal to 8. Therefore, we have taken 8 vertices and which has P degrees. See in this graph, V1 and V5 will equally separate the vertices, that is V2, V3, V4 and V6, V7, V8. These vertices V1 and V5 will equally separate our graph. And here V1, V2, V3 and V4 will exactly Hop dominate all the other 4 vertices. Therefore, our Hop domination number is n by 2. So here our n is 8 and our Hop domination number is 4. And the next theorem is for an even degree P regular graph with n equal to P plus 1 into m and m is equal to 2, 3, 4, etc. Our Hop domination number will exactly equal to m. So here we are going to consider P regular graphs with n equal to P plus 1 into m. Now I am going to prove the result for m equal to 2, that is n equal to 2 into P plus 1. So here the vertex set will be V1, V2, etc. V2 into P plus 1.
Now the vertices V1 and Vp plus 2 will separate our graphs equally. And now here our Hopf domination set will be V1 and Vp plus 2. Since V1 will exactly perfectly Hopf dominate the neighbors of Vp plus 2, and Vp plus 2 will perfectly Hopf dominate the neighbors of V1. So to prove the minimality, if we take a subset of SPH, that is the subset will be V1 or Vp plus 2. If we leave any one of these vertices, the neighborhoods of each other will not be perfectly Hopf dominated. Therefore, this SPH will be the minimum. Therefore, here our Hopf domination number is 2. And if we take n equal to 3, n equal to 3, that is our vertex set will be V1, V2, etc. up to V3 into P plus 2. Our Hopf dominating set will be V1, Vp plus 2 and V2, P plus 3. Here for each one vertex, for each P plus 1 vertex, a vertex will be perfectly Hopf dominating the other vertices. So V1 will perfectly Hopf dominate the neighborhoods of Vp plus 2 whose indices are less than P plus 2, and the neighborhoods of Vp2 plus 3 whose will perfectly Hopf dominate whose indices are greater than P plus 3, so 2P plus 3. And Vp plus 2 will perfectly Hopf dominate the neighbors of V2P plus 3 whose indices are less than 2P plus 3, and the neighbors of V1 whose indices are greater than 1. And V2 plus 3 will perfectly Hopf dominate the neighbors of Vp plus 2 whose indices are greater than P plus 2, and the neighbors of V3 P plus 1 minus P by 2 minus 1 whose indices are greater than 3 into P plus 1 minus P by 2 minus 1. So to prove the minimality, that is if SPH is not minimum, then we are going to choose a proper subset of SPH. So here we are going to choose the proper subset of SPH as SPH1, which can be we can either leave V1 or Vp plus 2 or V2P plus 3. So here first I have left V1. Therefore, our SPH1 is Vp plus 2 and V2P plus 3. So the neighbors of Vp plus 2 whose indices are less than P plus 2 and the neighbors of V2P plus 3 whose indices are less than 2P plus 3 will not be perfectly Hopf dominated by any one of the vertex in SPH1. Therefore, SPH1 is not minimum. Similarly, if we leave any of the vertices Vp plus 2 and V2P plus 3, the other vertices will not be perfectly Hopf dominated. Therefore, our chosen SPH is the minimum set. Therefore, our Hopf domination number is 3 here. So here we have proven for m equal to 2 and m equal to 3. So here I have taken the general set vertices of regular even degree vertices V1, V2, etc. up to V m into P plus 1. So we have given the perfect dominating set of this graph as SPHs V1, Vp plus 2, V2P plus 3, V3P plus 4, etc. up to Vn minus P. Since we may choose for every P plus 1 vertices, we choose a vertex for every P plus 1 vertices. Therefore, the cardinality of SPH will be equal to M. So here to prove the minimality, so if we choose a proper subset of SPH, for every P plus 1 vertices, we must have to choose a vertex so that its neighborhoods should be dominated. But if we leave any of the vertex in SPH, that the P plus 1 vertices will not be perfectly Hopf dominated. Therefore, this SPH should be the minimum. Therefore, our Hopf domination number is M here. So in this example, we have considered P equal to 4. That is, we have taken 4 regular graphs with n equal to 5m. That is, here we have chosen m as 2. Therefore, it is 10 vertices. 10 vertices with 4 degrees of the vertex are 4. So here the marked vertex V1, V6 will be the Hop dominating sets. Since here m equal to 2, our Hop dominating number will also be equal to 2. So next I have chosen m as 3. That is, we have taken 15 vertices, each of degree 4. Here V1, V6, V11 are the Hop dominating vertices. Here our Hop dominating number is 3. So next I have taken a P regular graph with P equal to 4m and m equal to 3, 4, 5, etc. and n equal to P plus 3. That is, if m equal to 3, P will be 12 and n will be 15. So the perfect Hop domination number is given by P plus 3 by 3 if P plus 3 is congruent to 0 mod 3 and P plus 3 by 3 plus 1 if P plus 3 is congruent to 1 mod 3 and P plus 3 by 3 plus 2 if P plus 3 is congruent to 2 mod 3. So here we have taken the vertex set as V1, V2, etc. Vp plus 3 as our n equal to P plus 3. So choosing V1 in the perfect Hop dominating set, Vp plus 2 plus 2, sorry, P by 2 plus 2 and Vp by 2 plus 3 are perfectly Hop dominated. And choosing Vp by 2 plus 4 in SPH, V2 and V3 will be perfectly Hop dominated. On choosing V4 in SPH, Vp by 2 plus 5 and Vp by 2 plus 6 will be perfectly Hop dominated. So proceeding in this way, exactly 2 vertices can be found in V difference SPH perfectly Hop dominated by V. So by this there arises 3 cases. The first case is P plus 3 congruent to 0 mod 3. Since every vertex in SPH exactly perfectly Hop dominate 2 vertices in V difference SPH.
Excuse me, ma'am.
SPH, yes sir?
Could you please conclude it because we are lagging behind
Yeah,
time.
yeah. Okay, sir. So in this theorem, we have 3 cases. By the first case, there will be P plus 3 by 3 vertices. And in the next 2 cases, there will be, in second case, one vertex will be left perfectly not Hop dominated. So by choosing Vp by 2 plus 2, it can be Hop dominated. And in the third case also, by choosing other 2 vertices, it can be perfectly Hop dominated. So by this, we can get the result. And next theorem is, if we take a P regular graph with P equal to 4m plus 2 and m equal to 1, 2, 3, etc. The perfect Hop domination number is given by P by 2. So in this case also we will be having 3 cases. P plus 3 is congruent to 0 mod 3 and P plus 3 is congruent to 1 mod 3 and P plus 3 is congruent to 2 mod 3. The proof is same as the previous theorem. So here my conclusion is the Hop domination number of even degree P regular graphs are n by 2 when n equal to P plus 2 and it is m when n equal to m into P plus 1. Any queries?
Yeah. Any queries? Okay, thank you, ma'am.
Thank you, sir. Thank you so much.
And now I request Sushant Yadav to please present your paper. Some properties related to a hypergeometric and extended hypergeometric function. I request you to kindly keep your presentation brief and short.
Yes, sir.
Yeah.
Yes, sir. Sir, my screen is visible.
No, it's not visible.
So now, now it's visible, sir?
No, it's not visible. Not yet.
Sir, call the next substate, I think, 1026, Jugal Kishore Sharma.
Yeah. Okay. Now I request Jugal Kishore Sharma, 1026 on. He have already presented. Yeah. As per it, Vijaya A will be the next participant. Serial number 16. Yeah.
Sir, may I? Okay,
Yeah.
sir. Thank you.
Please keep your presentation very brief because we are already lagging behind. Thank you.
Okay, sir. Sir, is it visible?
Yes.
Sir?
Yes.
Yeah, it is visible and you are audible too.
Okay, sir. Okay, sir. Thank you. Then my topic is perfect Hopf domination number of irregular graph of odd degree vertices. Now I am going to that notation R N O is represented that R is regular graph and then O is odd degree, N is number of vertices. Then it is a P regular graph of odd degree is set SPH, that is the perfect Hopf dominating set notation, which is a subset of vertex set of G. I simply said G is a perfect Hopf dominating set of G. If for every V in that V of G minus SPH, there is exactly one vertex U in SPH such that the distance between U and V equal to 2. And then the perfect Hopf dominating set with the smallest cardinality is called the perfect Hopf domination number of RNO, denoted by gamma pH of simply denoted by G. In this presentation, we have discussed about the perfect Hopf domination number of P regular graph of odd degree. I have two results here. The first one is for an odd degree P regular graph with N equal to 2P, the perfect Hopf domination number is 2. Let the vertex set of G is V1, V2, etc. V2P. Here, that V1 and V plus 1 separate the vertices of graph equally. See the illustration. Here we have 6 vertices with degree 3. That V1 and V4 are separate the graph vertices inequally. Then we may choose that perfect Hopf dominating set is V1 and VP plus 1. That V1 is perfectly Hopf dominated to the neighbors of VP plus 1, and VP plus 1 also perfectly Hopf dominated on neighbors of V1. That is, see the illustration, that V1 is perfectly Hopf dominated V3 and V5. That yes, V2 and V6 are perfectly Hopf dominated by V4. That is, then we have to prove the minimality of the set. We choose SPH1 from SPH, which one is subset of SPH. That is V equal to V1. That VP plus 1 is VP plus 1 alone SPH1. Then we have all the vertices adjacent to VP plus 1, not perfect Hopf dominated by VP plus 1, which is equal to SPH1. Therefore, SPH1 is not minimality. Hence, SPH is perfect Hopf dominates RNO. Thus, SPH is minimum. Hence, that gamma pH equal to 2. Then the next result is
For an odd degree p regular graph with n equal to 2 into 2p minus 1 into m, the perfect half domination number is gamma ph equal to 2m, where m equal to 1, 2, 3, etc. First of all, we may prove that m equal to 1, then next m equal to 2, then hence the general proof. Let v of g equal to v1, v2, etc. v4p minus 2, and also v1 and v2p separate the vertices of graph equally. We have given the perfect half domination set of this graph as SPH equal to v1 and v2p, as well as the neighbors of v1 is perfectly half dominated by v2p, and then the neighbors of v2p is perfectly half dominated by v1. Suppose this SPH is not minimum, then the proper subset of SPH is SPH should be minimum, which is SPH1. That SPH1 equal to, I will take V2P alone. Then we have all the vertices adjacent to V2P not perfectly half dominated by SPH1. Hence, that SPH1 is not minimum. Therefore, SPH is minimum. So, the cardinal gamma pH equal to 2. The next one is the next which means m equal to 2. The proof. Let v of r n o equal to v1, v2, etc. v4 into 2p minus 1. Here also v1 and v4p minus 1 separate the vertices of graph equally. Then we have the perfect half dominating set is v1, v2p, v4p minus 1, v6p minus 2. Since we may choose a vertex for every 2p minus 2 vertices. Note that v1 perfectly half dominates neighbors of vp plus 1 whose indices are less than p plus 1, neighbors of v7p whose indices are less than 7p, and all the neighbors of v4p minus 1. For the reasons for v2p, v4p minus 1, v6p minus 2 also. Hence, now we have to prove the minimality of this set. That is a proper subset of SPH is SPH should be perfect half dominates this set. So SPH1 equal to SPH minus V, which means we will take V equal to V1. Then the set is V2P, V4P minus 1 and V6P minus 2. We have all the vertices adjacent to V4P minus 1 and not perfectly half dominated by any vertex from SPH1. Hence, SPH1 is not perfect half dominating. The half dominating set. Hence, similarly, we have to prove V2P, V4P minus 1, V6P minus 2. Then SPH is minimum. Then gamma pH equal to 2m. In general proof is same. Let the vertex set V1, V2, etc. V2 into 2P minus 1 into m. Note that V1 and V2 into 2P minus 1m by 2 plus 1. Separate the vertices of graph equally. Here also the proof is same followed here. And then SPH equal to V1, V2P, V4P minus 1, etc. V2 into 2P minus 2m minus 2P minus 2. Since we may choose a vertex for every 2P minus 2 vertices. Thus, cardinality of SPH equal to 2m. Now we have to prove the minimality of this set. As well as the proper subset of SPH is not minimum, then there is a proper subset of SPH perfectly half dominating RNO. If V belongs to SPH, that is V equal to V1 R, etc. V equal to V2 into 2P minus 2 M minus P 2P minus 2. If V equal to V1, then SPH1. We have all the vertices adjacent to V2 into 2P minus 1 into M by 2 plus 1, not perfectly half dominated by any vertex 1 SPH1. Therefore, SPH1 is not a perfect half dominating set. Similarly, for other vertices from SPH1. Hence, SPH is SPH is perfectly half dominates RNO. Thus, SPH is minimum, hence the perfect half domination number is equal to 2m. That's also illustrate the two figures for p equal to 3 and then n equal to 2 into 2p minus 1 into m equal to 1 to 3. Here I choose 10 vertices with degree 3. The degrees, the vertices v1 and v6 are perfectly half dominates all the vertices, and also this I will choose the vertice number of vertices equal to 20, and then degree is all the vertices having degree t3. We may choose vertex for every 5 vertices once. So this v1 and v6, v11 and v16 are the perfect half domination dominates the graphs. Hence, my conclusion is that both theorem statements, and then it's over. Any queries? Excuse me, any queries?
Yeah, thank you. Thank you for your presentation.
Thank you. Thank you very much.
Yeah. Now I request 1026 Jugal Kishore Sharma ji to present. Are you here?
Sir, you just call 1028.
Okay. Now 1028 Sushant Yadav.
Yes, sir.
Yeah, please present.
Sir, now it is presenting?
Yeah, it's presenting now.
Okay, sir. So myself, Sushant Yadav. I am from MIT University, Noida. And the presentation of my title is a study of some properties related to the hypersymmetric and extended hypersymmetric function. So the overview of my presentation is basically what is hypersymmetric function and right hypersymmetric function and their integral representation. After that, the Bessel-Smidt function and their extension, and then Mittag-Leffler function and the pathway fractional operator. So the aim of my research is basically the first objective is to obtain an integral involving the hypersymmetric function by combining an integral obtained by Macrobert and Batman. Secondly, the objective is to establish a new generalization of Bessel-Smidt function using the extension of beta function involving a Mittag-Leffler function, and then applying the pathway fractional operator and the pathway fractional derivative operator, which is expressed in terms of a generalized right hypersymmetric function. Then discuss the properties related to it. So the basic definition of the Gauss hypersymmetric function, basically, which is a special function represented by the hypersymmetric function that includes many special functions as specific or limiting cases. So basically, this is the mathematical expression, and here alpha sub n, beta sub n, and gamma sub n is a post-Hammer symbol, and the condition for the alpha beta, which is belong to the real number, gamma is any real number such that gamma is not equal to 0 and negative numbers. Here this z basically satisfy the modulus of z is less than 1. Now the generalized hypersymmetric function, this is the generalization of the hypersymmetric function FPQ, basically a power series in which the ratio of the successive coefficient indexed by n in a rational function of n. Basically, we will go through the two unique generalized hypersymmetric cases of this generalized hypersymmetric function. When we put p is equal to 2 and q is equal to 1, then we will get a generalized we get a Gauss hypersymmetric function. And when we put p and q both is equal to 1, then we will get a confluent hypersymmetric function. The convergent condition for the hypersymmetric function is when p is less than equal to q, then modulus of z is less than infinity, then it is converges, and the modulus of z is less than 1 if p is equal to q plus 1, then it is also converges. And the another condition is the converges for all z when z is not equal to 0 if p is greater than q plus 1. Then come to the integral representation. This is an integral representation of Gauss hypersymmetric function, which can be written in this form: the limit from 0 to 1, and the condition is gamma is less than beta is less than 0. Then come to the right hypersymmetric function. Right hypersymmetric function has an interesting role in research and many applications in research various areas of mathematical science, theoretical physics problem, and probability theory. This is the mathematical expression where A1 comma capital A1 is a post-chamber symbol, which is extended post-chamber symbol. When we are normalizing this mathematical expression, then we will get this second expression. And when we put A sub 1 up to P, B sub 1 up to Q is equal to 1, then we will get this result. Now come to the Bessel-Smidt-Line function, which can be written in the form of J sub V lambda Z, which is defined by this mathematical expression. Here the condition is lambda is belonging to the real number and Z is belonging to the complex number. After that, this is the extension of generalized form, where the condition where we are just introducing a post-chamber symbol lambda J sub M, V J sub M. This is the Bessel-Smidt-Line function in terms of beta function. Basically, this is our motivation of our research paper, where F1 is an Apple series, and this Bessel-Smidt-Line function written in the form of beta function, and this beta function is written in the form of Apple series, like you can see that in the below of extension of beta function using the Apple series. Now the Metcalfe function. Metcalfe function, the Swedish mathematician Gösta Metcalfe introduced the function E epsilon R, which is basically written in the form of this, and where the epsilon is greater than equal to 1 and R is belonging to the reference number. After that, Prabhakar introduced the function in the form of this way, where this is basically just an extension of it. And here is a M parameter function, which is basically M parameter in this function, and this is extensive version of the Metcalfe function. Now come to the partial fractional integral operator. Fractional integral operator are extensively used in the large number of area of mathematical analysis. Basically, partial fractional operator is based on the well-known RL fractional operator and partial module. This is the first lemma which is used in our result. Rho and lemma 1. Rho n is belonging to the complex number. The real part of neta and real part of rho is belonging to the is greater than 0, and v is less than 1, and real part of neta upon 1 minus mu is less than greater than minus 1. Then we get this result. In the second result, we are just increasing one parameter. Here we are using a neta. In the first lemma, we are using neta and mu. In the second lemma, we are using neta, lambda, and d. This is the fractional derivative operator which we are using. Derivative z mu z raised to power n p v, and this lemma is used basically in our derived result. So this is our main work, and integral representation of generalized hypergeometric function with the different argument. We are using one result which is given by Batman. This result, the result is in the form of beta function. So the first theorem, basically in this theorem we are using FPQ hypergeometric function, and the argument is y, and basically we will get the result in the form of p plus 1 fq plus 1, and the argument basically the argument which we are using y, it follows the same condition as the hypergeometric function, as I previously see in the hypergeometric function. And this is the special case of this function. When we putting the value p is equal to 2 and q is equal to 1, then we will get the result in such a way. 2f1 is getting changed into a 3f2. Similarly, the another result when we are using a Gauss theorem. In this theorem, similarly, we are changing the argument, and then we will get this result in the form of hypergeometric function and the beta function. And then when we are putting the value p is equal to 2 and q is equal to 1, then we will get the result in the form of 4f3. After that, using the result given by MacRobert, which is similarly as, but here we see one changes. When we are using pfq, then we will get the result p plus 2 f plus 2, like as we see in the theorem 2.5. The function which we are using is f1 and we will get the result in the terms of 3f3. After that, as I see previously, as we see previously, the generalization of Basel-Smittland function in terms of Apple series. Here we see that the Basel-Smittland function, which is in terms of beta function, and this beta function involving a Mitiglyfer function, like in this way, and then we are operating with this pathway fractional operator with this Basel-Smittland function here. In this section, we consider a composition of a pathway fractional integral operator with the multi-indexed Basel-Smittland function and obtain a result in terms of Fox right hypersymmetric function. Theorem 4.1. In this, there are some cases, conditions which are required to prove this theorem. V, rho, gamma, sigma, delta is belonging to the complex number, and the real part of V is greater than Q, and the real part of mu V is greater than equal to 0, and omega is any number 0, 1, 2, 3 up to PQ, which is greater than 0. Basically, this is our proof, which is in terms of right hypersymmetric function, and this is a special case of if we put neta is equal to neta minus 1, lambda tends to 0, and d tends to 1. Then we will get this result. Similarly, here when we are decreasing the parameter neta and lambda, before this term we are using neta, lambda, and d. Then we will get this result, and this is also in terms of right hypersymmetric function. After that, this is then derivative. When we are operating a differential operator on it, then we will get this result, and which is also in terms of right hypersymmetric function. And we can also, using the transformation formula of external beta function, then we can also prove this Basel-Smittland function in terms of right hypersymmetric function. So my conclusion is, in the initial part, the integral which is expressible in terms of beta function and the generalized hypersymmetric function PFQ in terms of P plus 2 or F plus 2. If we again put many efforts in the parameter PQ, we will get this enhanced result. In the second part, the theory of pathway fractional operator, which we are operating on the Basel-Smittland function, we will get the result in terms of Fox hypersymmetric function. This result is also expressed using a variety of functions such as Fox hypersymmetric function, and we have a definition. We have defined a new generalization of Basel-Smittland function using an extension of beta function. My future work is basically explore integration of pathway fractional operator in machine learning algorithm and model investigation, how fractional operator can enhance the representation and machine learning capability. These are my references. Thank you so much.
Thank you. Any questions from the audience? Now next presenter is Jugal Kishore Sharma, 1026. Jugal Kishore Sharma, are you there? Jugal Kishore Sharma. Jugal Kishore Sharma, am I audible? But you are not audible. Now move to the next as Tamil Selvi. Please be continue.
Yes, sir. Thank you for the organizer for giving me one more chance. Due to bad weather, my network got interrupted in between.
Thank you, ma'am. Thank you.
My screen is visible.
Yes, sir.
So my title is a comparative study and analysis on medical image denoising by using filtering and transform methods. And I'm a research scholar in Jaipur National University, working under the guidance of Professor Hoshiar Singh, and my co-supervisor is Dr. S.M. Kerna, Professor Ajinkya D.Y. Patil, School of Engineering. And I'm just skipping some of my previous things and directly going to my.
Your screen is blank.
What is it?
Your screen is blank. White, only white screen we have. Yes, now it's visible.
Okay. Basically, my paper is to denoise it's a comparative and analysis of medical image denoises by using filtering methods and transform domain methods. And in filtering method, there are two types of filters. One is linear filter and other one is non-linear filter, which are used to eliminate the noises which are present in the images. And my focus is only medical images. And some of the transform domain methods are Fourier transforms, wavelet transforms, discrete wavelet transforms, stationary wavelet transforms, dual tree wavelet transforms, curvelets, ridgelets, riplets, counterlets, Schurler transforms. And as every transforms we have applied, and there are some of the advantages and limitations are there. So my objective is to make a hybrid model by using the curvelet and Schurler transform. That is my research topic. And basically this paper is a comparison and analysis of between the filtering techniques as well as the transforms. So here in linear filters, averaging filter, median filter, and some of the filters have been used in analysis by the previous some of the researchers, and that references has been taken as a literature review, and the research gap has been identified, and the limitations for use after using every filter in the medical images has been noted down. And next, in transform methods also, the research, some of the research had happened earlier by using Fourier transforms, but Fourier transforms is only having the signals are localized only in the frequency domain, and it has less useful in non-stationary signals. So not appropriate and suitable for every stationary and non-stationary signal. And since it is focused only in the frequency domain. And next comes the wavelet transform. Signals are localized here in both time and frequency domain. And here the sharp spikes, whenever the signal upgrades are there, that can be captured, denoised in a proper way. And here also the disadvantages and limitations are there, as whenever the curve effects are there, that time the wavelet coefficients is not working well in handling the curves as well as discontinuities. And next one is controllet transforms. And here this controllet transforms by author MD in 2011, high PSNR values and can remove the Gaussian and white random noises, but it is not suitable for multiplicative noise. As we know that there are two types of noises available in our image. One is additive noise and other one is a multiplicative noise. This multiplicative noise denoising is a little bit complicated task. For that only my research is focused. And I'm using a hybrid model of curvelet transforms and Schurler transforms, especially in medical COVID-19 X-ray images, in order to denoise it. Why this is necessary? What is the need for it? Because in nowadays, in digital era, accurate disease diagnosis is very, very important. Once the disease is diagnosed accurately, then only the treatment can happen. And after using all those things, some of the image quality metrics has been used to test the quality of the image after denoising. One is peak signal to noise ratio, and other one is mean square error. And the basic formulas has been used to calculate, because original image will be having X-ray image has been taken from the Kaggle database, and it has been analyzed. It has been experimental, has been set up, has been done in MATLAB. And I'll just show you some of the results. So here originally some of the from Kaggle data set, many images has been taken, X-ray images has been taken, whether it is COVID-19 positive or negative or it is normal, all some of in I think 597 databases has been taken from Kaggle data set, and then that has been used in the MATLAB software, and various types of filters has been applied over there. First, the noise has been introduced, additive noise as well as multiplicative noise. And this image, the first is the original image, then the speckle noise has been introduced in it. And after introducing the speckle noise, then average filter techniques has been used for denoising. And the fourth image is showing the median filter, where it is used to suppress the noises. And next, this is also in some more filters which I have applied and tested for denoising. Original image, then noisy image, and the third one shows the denoised image using Gaussian filter, which follows the Gaussian distribution, and the denoised image using the Wiener filter. And this one is original image, and noise has been introduced over there, especially the speckle noise and salt and pepper noise. And in all angles, the noise has been introduced. That is in vertical, horizontal, as well as the diagonal. And here in this image, the wavelet transform has been used to denoise the image. That is the fourth figure. It is the denoise way, but the quality check has been done by using the image quality metrics, that is mean square error and peak signal to noise ratio. So the various filters used and what are the mean square I have calculated, we got as per in the experimental setup. And whenever the error is low, that is the mean square error, then it is more appropriate. And peak signal to noise ratio, it is measured in decibel. And here also, the higher the peak signal noise ratio, that will be the most clear, that is that denoising has happened at most 90% level. And the conclusion and scope is, after applying additive noises and multiplicative noise in X-ray images, various techniques has been used to denoise and found the nonlinear filters work better in speckle noise and wavelet transform working more better. But it still have flaws. That's why I am making a hybrid model of shearlet and curvelet transform. So these are some of the references.
Thank you very much, ma'am. The house is open for questions. If anyone has any question, they can raise here.
Yes.
Okay. I don't think there is someone. Okay, thank you very much, ma'am.
Thank you, sir.
I call Neelam Mishra, ma'am,
Yes, sir.
for the topic preparation and mechanical characterization of unidirectional glass fiber reinforced epoxy composites. Ma'am, I request you to be very precise and short. Thank you.
Visible, sir? My presentation?
Yeah, it's visible.
Yes, sir.
Yeah, it's visible. It's visible.
Visual, sir?
Yeah, kindly start presentation. Open your PPT, ma'am.
Okay.
Just open the PPT, ma'am. We can see your screen.
One second, sir.
Now it's not visible.
Pushparaj sir, meanwhile call to the another participant, I think.
Yeah, sure. Yeah. Dr. Rashmi Jain, is she here?
Yes, I
Yeah,
am.
yeah. Are you ready with the presentation, ma'am? Yeah,
Yes,
please
sir.
proceed, ma'am.
Is it visible to us?
Yeah, it is visible.
My screen is visible, sir?
Yeah, it's visible and you are audible also.
Okay, sir. I'm starting. Good evening. Myself, Rashmi Jain, Assistant Professor. Today, my topic is based on the soil physics. Is the determination of soil texture class by using USDA, United States Department of Agriculture, soil texture triangle. My topic concludes following points. Introduction, soil separates, sample collection sites, USDA soil texture triangle, soil textural analysis and classification using USDA model, result and discussion, conclusion, and at last references. Let's start with the introduction. What is the soil texture analysis? When we do the soil texture analysis with the help of some mechanical process, we determine the percentage of sand, silt, and clay. These are the three main components of any soil. When we find this, we use the soil texture triangle, which is given by the USDA, to determine the soil classification. What are the soil separates? There are three different type of groups that are called soil separates. These are sand, silt, and clay. In these three, sand are very coarse particles, silt and clay are smallest and fine particles. Soil texture is mainly determined by finding the relative proportion of soil separates, these three separates. On the basis of the size, soil separates are three. Sand is from 2 mm to 0.05 mm. Then silt is 0.5 mm to 0.002 mm, and clay is less than 0.002 mm. The USDA department gives the this classification on the basis of their size. Why these three separates are important? As we know, every separate has its important characteristic. On the basis of characteristic, we can determine which type of soil is better for our purpose. Different characteristics are looseness, air space, drainage, tendency to form clots, ease of working, moisture holding capacity, and fertility. As we see in this figure, in this table, all the three separates have different properties according to which we can choose a particular soil for our purpose. I have worked on the river-based soil. That river is on the Bilaspur city, Chhattisgarh. That is the Arpa. This is the lifeline of Bilaspur city. I have collected 6 different samples from this river from origin to the meeting point. First point was collected from Pendra Road. That is the origin point. Sample 2 is collected from Sandri. Sample 3 is Indira Setu. Sample 4 from Chhat Ghat. Sample 5 from Dari Ghat, and sample 6 is at the last point, Bartori. Method for soil textural analysis. The laboratory process by which we determine the percentage of soil separate sand, silt, clay is known as the mechanical analysis. There are different type of analysis process, but in my project, I use the international pipette method for determining the percentage of soil, sand, silt, and clay. Basically, this method is based on the sedimentation, means different type of size particle fall at different velocity. And when these particles fall, we recorded the time because every weight particle have taken different time to settle down at the bottom of the filled cylinder. This is the figure that I have worked, diagram that I have used in the laboratory. Main topic is USDA soil texture analysis. As you see, this triangle is divided into 12 different texture parts. The name of all is given. How we work. Next topic is how we work on this. As we see, this is my first sample. This is my first sample. First, I determine the percentage of all the three samples. As we see in this sample 1, sand is 49%. As you see in the figure, at the bottom line, you can see the percentage sand. The blue line, as you see, the blue line represents the 49%. In the table, silt is 23%. In the left side line, we see 23 by the red line. And the clay is 28%. The right side percentage of clay, you see 28% is determined by the green line. When we see all these three separate, sand by red line, silt by blue line, and clay by green line, all these three lines made at a single point, intersection point. This point falls on which category that determine the class of that sample. In this sample 1, this is the sandy clay loam. Again, I repeat, in sample 2, sand is 59%. This is determined by the blue line, 59%. Silt is 15%. That is represented by the red line. And clay is 26%. That is represented by green line. All these three lines intersect at a point that is sand, clay, and loam. In sample 3, that is different from the other two. Sand is 90%, which is again represented by blue line, and all the three separates are represented by blue, green, and red line. All the three intersect at the point sand. So the class of this sample is sand. Same sample 4, sample 5, sample 6. On the basis of this triangle, we can determine the result. As we see, all the 6 samples has its classification. Sample 1, sandy clay loam. Sample 2, sandy clay loam again. Sample 3, sand. Sample 4, sandy loam. Sample 5, loamy sand. And sample 6 is sandy clay loam. Why we are doing this? On the basis of this result, we find that sample 1, 2, and 6 are sandy clay loam. Depends on the texture of the soil, we can grow particular type of crop and vegetable. In sandy loam soil, tomatoes, pepper, and green beans are grow easily, and its growth is very, very good. Sample 3 is sandy loam. In this type of soil, radish, carrot, tomato, zucchini, corn, this type of vegetable and plants grow definitely. Sample 4 is sandy loam. And this is the list of the vegetable that can be grow easily in this type of soil. Sample 5 is loamy sand. On this type of soil, wheat, sugarcane, cotton, jute, etc. can be grown easily. Now the question arises, why the important to find to determine the soil texture? Soil texture is very important to find the soil productivity. On the basis of soil texture, we can find the amount of nutrients that can be stored in the soil, and also it is important to support the microorganisms that remain in the soil. It is possible for a farmer or a gardener which type of crop can be grown on a which type of soil. By finding the texture, they can easily determine which type of soil is beneficial for them. Also, soil texture is important to find the proportion of air and water. These are very important two factors for the growth of plant. And next point is the soil porosity. Soil porosity is very important because it is directly related to water holding capacity and gaseous infusion and water movement. Conclusion: role of physiochemical property. As this soil texture is a very important physical property. Similar other physical and chemical properties are also found. On the basis of this, we can easily find the soil fertility and crop production. Soil texture is very important because we know, by knowing this, we can easily find which type of crop and vegetable are important to grow for us. River-based soil is very important type of alluvial soil. This play an important role because it is very highly fertile. My work is important in the soil physics, which is useful for the farmer and gardener. These are the references. Thank you for paying attention.
Yeah, thank you very much, ma'am. Now I request Neelam Mishra ma'am to present the paper.
Yes, sir.
Yeah. Are you ready with the presentation, ma'am?
Yes, sir.
Yeah, please present.
I think there are some problems.
In that case, just read your findings in a minute or two.
Sir.
Yeah.
Sir, can you visual, sir? Screen?
Yeah, it is visible. It is visible.
Yes, okay, okay, sir. Good evening to everyone. Myself, Neelam Mishra. I am MTech student from Production Engineering from SIT College of Engineering and Technology, Prayagraj. Today, my research topic is unidirectional glass fiber reinforced epoxy composite, which is doing under Professor Dr. Ansuman Srivastava. Introduction. Composite. Composite is one of the most advanced and versatile engineering materials. Composite of material produce a combination properties of two or more materials that cannot be achieved by either fiber or matrix. When they are acting along, fiber reinforced composite were successfully used to many decades for all engineering applications. This is a unidirectional glass fibers. Material are used in manufacturing of composite, unidirectional glass fibers, epoxy resins, NY556 grade is used to epoxy resin, and hardener HY951 grade is used to hardener. Flow chart of the glass fiber reinforced polymer matrix composite. Preparation of the glass fiber reinforced polymer matrix composite. Mechanical properties of glass fiber reinforced polymer matrix and vibration behavior of glass fiber reinforced polymer matrix composite, and environmental properties of the glass fiber reinforced polymer matrix composite. Thermal properties of glass fiber reinforced polymer and tribological behavior of glass fiber reinforced polymer composite. Application glass fiber reinforced polymer matrix composites. Types of method. Hand layup method. Out of all the fabrication techniques, hand layup techniques is the one of the oldest method and least expensive in the comparison to other. Hand layup techniques is also called wet layup technique method. This process can only produce a small number of parts. It is not appropriate for the mass manufacturing. This procedure produce good like a dark coal furnishing sales lines etc. for the less money. Following the preparation of the mold, fiber are manually laid up in various orientation according to the desired quality. The matrix material is now added and it is heated and subjected to high pressure to blend with the fiber. The composite is given some time to cure or completed. This is a hand layup technique. Some figures. And hot press method. Prepare the woven mat glass fiber reinforced epoxy composite using hot press techniques. Dry hand layup method. Prepare the woven fabric glass fiber reinforced vinyl ester composite using dry hand. Classification of the glass fiber matrix composite. Classification glass fiber physical properties. Classification and physical properties. A glass higher durability strength and electric resistivity. C glass higher corrosion resistance. D glass low dielectric constant. E glass higher strength and electrical resistivity. AR glass alkali resistance, and R glass higher strength and acid corrosion resistance. S glass higher tensile strength, and S2 glass higher strength modulus and stability. And A glass fiber, they are highly alkali glass with 25 soda and limes. They are used as filler as plastic industry, as they are cheap and easy to manufacture. Though they have poor chemical resistance to water and alkali line media. Sea glass fiber, they have high chemical resistance to corrosion, so they are used in contact with acidic materials. However, they have low strength property. T class fiber, they have greater electrical property and low dielectric permeability. So they are used in electronic broad and reinforcing material. However, they have low strength and poor chemical resistance. S class fiber, they have a high strength modulus of elasticity, corrosion resistance with low dielectric permeability. Unfortunately, they are difficult to manufacture and thus are expensive. AR glass fiber, they have high resistance to crack propagation and great impact strength due to presence of zirconium. However, they are high melting temperature that resists the application. E-glass fiber, they are electric glass fiber and are the most used type of the glass fiber due to their low cost, high electric insulation and high water resistance. They are chemical composition of the glass fiber in weight percentage. They are physical and mechanical properties of glass fiber. Fabrication of composite. There are many composite manufacturing techniques available in industries such as compression molding, vacuum molding, and the hand layup manufacturing process. Compression molding is the process of molding in which the feeding material is placed into an open hand molding activity. Vacuum molding is a straightforward molding process that uses vacuum pressure to force a sheet of heated and stretched plastic into a single surface mold. Hand layer manufacturing process. Hand layer manufacturing is the most common and least expensive open molding because it is required the least amount of the equipment. Fiber reinforcement are placed by hand in mold and designed to apply with the brush or roller. This process is used to make both large and small items. This is a figure mixing the epoxy and hardener and hand layup method using by roller and vacuum bag. Properties are composites. The properties of composite can be affected by many factors such as form of fiber, the quantity of fiber, interfacial bond strength between the fiber and matrix. Glass fiber. Glass fiber is also known as the fiberglass. Glass fiber is the name given to the material produced from very thin glass wire melted from mold. Preparation of the glass fiber mat. In this figure. And properties of reinforced glass fiber materials. Statics, fracture mode, dynamic fracture load, fracture strength, elastic mode is compressive strength and tensile strength. Static fracture load, the load which is the which if placed upon the structure or rest piece is just great enough to break it. Dynamic fracture load. Dynamic fracture is used to describe the crack growth process accompanied by the rapidly occurring change in loading and crack structure geometry, where these cases are not well described by a sequence of static equilibrium state. Flexural strength. The flexural strength is stress at failure in bending. It is equal or slightly large than the failure stress in tension. Elastic modulus. The ratio of the force exerted upon a substance or body to the resistance deformation. Compressive strength. The resistance of the material to breaking under compression. Tensile strength. The resistance of a material to break under tension. Application of the glass fiber reinforcement polymer. Electronics, home and furnitures, aviation and aeroplanes, boats and marine, medical and automobiles. This is the application of the reinforcement polymer. Environmental behavior of the reinforced glass fiber reinforced polymer matrix composite. The effect of the weathering condition on the mechanical properties of the reinforced thermoset plastic composite. The mechanical properties were described decreased with various weathering conditions such as humidity, temperature, ultraviolet radiation, and propellant. Recent development of the glass fiber reinforced polymer composite. The glass fiber composite has found a host of the application in the automobile industry, marine engineering sectors, as well as other many due to the inexpensive and lightweight properties of the glass fiber. Recent study further diverse.
No, Neelam ma'am, kindly conclude your results.
Sir, last slide is explained, sir. Composite to change chemical composition of the classical silica glass and physical modification to impart self-healing properties using the composite as the reinforcement for the construction purpose, amongst many others. Nanoclane glass fiber hybrid composite are the latest development in the elevated erosion resistant materials. Sir, this is a review, literature review and references. Thank you, sir.
Thank you very much, ma'am.
Thank you, sir.
Yeah. Now let us invite our session chair to give his comments. Dr. Amit Goswami, please comment on the session.
Amit Goswami, are you there?
Yes, sir.
Can I do,
Hello?
sir?
Hello. Please provide your comments over the session.
Namaskar. This is a very intellectual, very knowledgeable, and every participant present good research work. I appreciate effort of Dr. Pritam Singh for organizing such a good events. And I suggest please organize theme-based next conference in theme-based on quantum computing. So more students in other organizations participate in this beautiful conference. Thanks for organizing such event. Thank you.
Thank you for your kind words, sir. We would be taking your suggestions. On the behalf of the organizing committee, we express our sincere gratitude to all the speakers, participants, and everyone involved in making this session a resounding success. We extend our best wishes to all of you as you continue your endeavors in academia, research, and professional pursuits. Let us disperse today and meet tomorrow at 9 a.m. sharp for the day 2 of the conference. Thank you very much. नमस्कार सर, क्या हाल चाल है?
हाँ सर, बोलो. हेलो. हेलो हेलो पुष्पराज सर
क्या है वो तो
गया, चलो फिर है ना, कल मिलते हैं।
रिकॉर्डिंग ऑन है, ऑफ करना और सेव करना और वो यूट्यूब पे डालो सर आप।
क्या रिकॉर्डिंग?
हाँ सेव कहाँ हो रही है ये?
सेव हो रहा है क्लाउड पे।